Hello. What's up, people? Hopefully I'm not forgetting anything. Oh, I am forgetting something. I need to have Discord open so that I can put the link in the Discord this way. Oh, another day of Chess Engine. Oh, I think I put it at okay, no, I did update it to 3. Episode 3. Excellent. Let me just put this in the Discord. So my music is a bit loud. Can't really hear myself. So today's exciting. Today is very exciting. Because today we are doing, probably going to be doing our first perf test if everything goes as planned. And that's what I have set up right here. So I have downloaded and installed Stockfish, which, if you don't know, is, you know, like one of the fastest chess engines. Is open source, and it's perfect for evaluating positions and making sure that we are generating all of the moves. And as you can see, I ran my first test here, which is from start position, and you type in go perf 5 and it performs this recursive test to find all of the possible moves, 5 moves deep. And that's what this node searched is this number that is 4 million different move combinations, which is a large amount of different nodes. And that is the number that we want to see replicated on our end. I forget the commands to I think you just do okay, so this isn't the command. Interesting. Yeah, I don't really know what the command is, but there is a command to do a certain move, and then you run the perf test from that move. And what that basically does is it's basically if our number is off, right, which it most likely will be, then what we can do is we can perform a move and then go down the tree, basically, to find exactly where our numbers are off, to find what edge case we are off on. So that's where this is really an amazing tool for us in terms of getting our move generation completely correct. Something else you might notice is that I am at 720p today because we were lagging before at 1080, so that's very unfortunate for everybody who enjoyed having crispy stream quality, but unfortunately typing with the lag and stuff, it just really bothers me, and then I get in a sour mood about it. So we're gonna keep it 1080p today. Hopefully the audio is good, and I think the stream is good. First of all, some things that you might notice. I got up this morning and I changed some things. I also had a crazy dream. It was actually very sad, scary, just a bad dream. I was back in high school, and I fell behind in this class. I guess my biology class, and it had the same teacher as my biology class in high school. I fell behind in the class, and instead of going to the class, I would just skip the class and just smoke cigarettes and walk around, and I would just skip the class, and then at the end of the year, I I I had to do the test, right? The final test for this class, and I did that test, and the 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 next it was like college, and we only had a class a week, so it was like college in high school. Anyway, a week later we got our test results, and she was handing out the papers, and she was doing the thing where she said our test scores out loud, right? And I knew that I had absolutely bombed the test, like to the point where I didn't know anything on it. And I'm always last because, and it's my last name. And she gets to my name, and she says my name with such insane disappointment, and then she doesn't say my test score, and she gives it to me, and I do the thing that I did when I was in high school, where I've always been very emotional and stuff. So what I would do when I knew that I had done bad on an assignment or anything was that, when I got it, I just wouldn't look at it. I would just put it down, face down, and just pretend like it didn't exist, and I did that. But yeah, there's like that kind of sinking feeling, and I think like maybe she talked with me. No, and then the week after that, when she was doing the review and stuff, and I had to look at it, and I saw all of the red marks, and I remember her like looking at me weird or something, and then I eventually just got to a tipping point, and I like stood up, and I just started like kind of just dumping, on the entire class. I was like, I'm so sorry, I fell behind in my schoolwork in this class, and then I stopped coming because I couldn't catch back up, and it was so incredibly stressful and difficult for me, and I'm so sorry, but yeah, anyway, it was a very sad dream, I guess, because it's I guess somehow subconsciously I've been thinking about, maybe it was this conversation with somebody in the chat that I had yesterday, where I thought about my own history in school. I was like a very bright student when I was in high school, but I always struggled in college because I would always at some point fall behind and not be able to like mentally recover, and some professors were okay with it. Some professors was totally cool, right? Like I remember I had this Russian literature class that I was super into, and I would read all of the texts, and we also would like watch plays and things like this, and I was always like so excited for the class, and I would always like participate in the class discussions and and stuff like this. And I went to like his poetry readings that the professor was doing. Anyway, I was really loved that class, but at some point I fell behind on it at the last few weeks of the semester, that and some other classes, and I was just crunching on, like, if you go to school for literature, the final papers are brutal, man. It's brutal how many papers you have to write. I had to write like 5 fairly long papers on literature, for each of the classes, and yeah, I was really behind, and he was really, really cool about it, because I hadn't come to class in like 5 or 6 weeks. I was just going through depression at that time because I had like fall behind in all my classes, and so my girlfriend and I were just like not going to class. Just, that was my way of dealing with it, emotionally, was just like avoiding it. But my paper ended up like a week late for that class, my final paper, and I emailed them and I said, I'm so sorry that, I haven't been to class in like a month and a half. It's been really hard for me, but, I said, I've continued to do all the readings for the class. And I did my paper, and it was on Notes from Underground by Dostoevsky. And I sent it to him, and he passed me with an A for the class, because he knew that, I guess he understood that I really cared about the class. It just, I have, my emotional, mental problems. But yeah, this was when I went to school for literature, But yeah, that's why college was always such a struggle for me. It's because once I fell behind in a class, it's kind of, I get very emotional, and there's kind of no way to deal with it other than just avoiding it. I've never been able to just like keep a clear head and, power through, so that, in combination with me just, having my bipolar episodes, it's very difficult. But, that semester I recovered, and the next semester I didn't. But I've went to college multiple times. But anyway, that's what my dream was probably, referring to, was, all of the leftover kind of mental anxiety I have around it's letting people down. Like, I have a fear of letting people down for sure. And that's why, even streaming is kind of difficult for me, because I don't want to, I guess, let people down. But anyway, what was I talking about? Oh, I was talking about what I did this morning, and then I thought about the dream that I had. But what I did this morning was I was thinking last night about ways to reduce branching now before we get deeper into the engine. And I've come up with a bunch of changes to how we have our layout for our game state position data. It's something that I should have changed earlier, but you're going to see all these things commented out, and I'll go through and talk about each one of them and what the reason why I'm changing it, right? So my idea here was to create all of these, pre-compute these masks that we use for bitwise operations during, checking if we can castle, right? But of course, we don't need to have these as different variables that we're going to check, in if statements. And basically the switch, you're going to see a bunch of errors here. But if I can show where this is exactly, oh gosh, oh my gosh, the stockfish files are inside of here. Okay, we're gonna have to deal with that because I don't want that. But what I want to show is, so when we're determining, this is castling and attack mask generation. Inside of here, we have a giant switch case that has these if statements, right, that are separate for black and white. It's much faster, logic-wise, to not have a switch at all, and instead just index into our into an array with our color enum, right? So if our side to move is white, we simply just index into the white castle masks with or whatever side we're checking, right? If it's queen side or king side. And so that's what we're going to be doing. This castle side max is 2, and we have queen side and king side here. And so that's so we just avoid branching right there. We don't have to branch at all when we're checking for castling rights. The same design philosophy is all over this now. For our pre-computed pawn boards and our pawn capture boards, we are indexing by color instead of having black pawn moves, black pawn captures. This again avoids branching, because if you can check where we do our generate pawn moves, we also are going to eliminate branching down there, but what I wanted to show is we have this switch case here that switches on our side and then tells us what our move boards are and our pawn capture boards are and which promotion rank we're going to use. Now we can just simply index into the correct one based on our color. So that's something that we're going to have to refactor a little bit. We also did this for our castling flags, which that's pretty self-explanatory, and for our board pieces, which has all of our white pieces, all of our black pieces, and both pieces. This is going to be color max +1 for the both pieces, right? And so all we're going to do when we need to check board pieces for the opposite side to move is simply just use that color to index into these board pieces and avoid a branch entirely. So that's the design philosophy that we're going to use moving forward, and I think that's pretty neat. We have some other things to talk about though. Most importantly is how difficult this specific change is going to make things for us. I made a similar mistake to my first engine here, and I didn't take into account the piece that we are potentially capturing. Why this capture piece is super important. Capture piece matters very importantly during move generation. The issue that we're going to come into, right, is in game.c. I started last night this make move function, which is, it's going to make the move, whatever move we decide. Obviously, right, the thing is, once we get into this function, technically, we don't actually need to know what piece we're capturing, because all we do, if we have a capture, is we just simply check the bits for all of the opposite color pieces at that position to check, which piece are we going to capture, which piece type, right? If it's a pawn, if it's a knight, or whatever, for the other color. So we don't technically need to know what piece we're capturing because we will find out here, right? The reason why you don't want to defer this to here is because of move ordering, which is something that isn't a concern yet, but will be a concern fairly soon once we start actually evaluating moves and create our Negamax routine. Move ordering is incredibly important because when you're 5 moves deep into a massive 4 million move recursive tree of moves, right, you don't want to be checking for every move. You only want to be checking for the best moves. And so what chess engines end up doing, right, is once you get deeper into the search tree, they only check the most valuable moves, right? And so what they do, right, is that they order their moves based on a few heuristics, right? But one of the most important ones is capturing valuable pieces, right? If you capture a piece greater than what piece you're capturing with, then obviously it's a good move, right? So let's say, somewhere in your search tree, a pawn captures a bishop, or something like this. This move is obviously going to be one of the first moves that you check, right, for evaluation. And you may not even check all of the moves that are possible from a given position. You only want to check the most valuable moves, right? And there's a bunch of different heuristics that we're going to eventually get in, like killer moves. I kind of forget all of the different ones, but we're eventually going to have a bunch of scoring, right, that basically gives a value for all of our moves, and then we order them before we start searching for all of them from a given position, right? The reason why I'm bringing this up now, though, is because this is why when we make a move, we should already know what piece we are potentially capturing. So we do not want to do this here. This was a mistake that I made with my first chess engine, is that I thought, well, who cares? Because once we make the move, then we're obviously going to find out what piece was at that location that we're moving to. But you want to know beforehand. You want to know beforehand because you want to know before you make moves what moves are good moves and what moves are bad moves. So that explanation hopefully is good enough, right, for you to understand why we need to have this capture piece on the move struct, and why at move generation time we need to find which type of piece we're capturing. The reason why we don't have that data already is because all we do to find out available captures is we simply have all of our moves from a given square, and then we just overlay that with the mask for all of the opposite colors pieces, right? That doesn't actually give us which type of piece, right? Because it's a bitwise operation with just two 0 and 1s, right? So we are going to have to write a loop that checks the piece. We'll get into my optimization for that in a second. Also, what we want to add here is a score value, and this is going to be int score. We aren't going to touch this yet, but this is, if we can write a comment here, this is for move ordering. We will not touch this yet, but this will be important later, okay? So I think that's all of the things I wanted to talk about at the start of today. Also, we have a new enum here, which is color castle side, which is different from castle side. I wanted an enum with this just in case we need to index an array of 4 and have all of the this will be, I think, important in our evaluation for positions, but that's much later down the line. So anyway, I hope that the resolution is good. I didn't really, I did some changes to make sure that we weren't lagging anymore. Okay, so with all of that being said, we have some refactoring to do, which is not very exciting, but we need to fix this now before it becomes even bigger problem down the line, right? When we generate our pawn boards, all of this black pawn moves, black pawn captures, we can actually just straight up go all the way down here and select all of that, right? So black, and we want to just pawn Actually, so let's go back. Let's undo that. And let's just grab black pawn moves. Let's only get the moves since they're different. And we want to go pawn moves indexed by black, right? That's how we're going to do it now. And we're going to do the same thing for the captures. Unfortunately, we are going to have to do this not only here, but we will also have to do this on our move generation. Oh, I forgot I, yeah, this needs I. So unfortunately, these are arrays of arrays, which when we're talking about memory isn't fantastic memory layout wise. But the thing is with contiguous memory, right, is that we will never be really going from black to white anyway. So we don't really care if they're contiguous because we won't have any cache misses because of this. I'm fairly sure that this will not impact that at all. At least, you know, that's what I theorize, right? I don't really know 100%, but that's what I theorize. Okay, and then let's do the pawn captures. And if you don't know what I'm talking about at all here, don't worry, it's just me being a dumb nerd. We will get to, you know, normal stuff in a bit. But we do have to go through all of these errors. Okay, so our blocker masks, this is going to be game board pieces white. And this update blocker masks, actually we should change this. This if statement, right? Instead of having these if statements and this, so this, what this loop does is that it basically says at every other number we will change color, right? Since our layout goes white black white black white black. But really, we you know, we shouldn't be doing this at all, okay? And the reason why is because we want to eliminate as much branching as possible, right? We want to eliminate this if statement. So what we should do is literally just hard code it. We don't need a loop at all. And reason being is because if we are having a standard game of chess, then we should never be going to piece types in extra. Now, if we eventually want to make a weird game of chess that has extra piece types, then that's a different conversation. But the design philosophy we should always have is actually hard coding things, which is not what I think, you know, is your instinct as a programmer. Your instinct is never to hard code, you know. So it's hard for me to just be like, oh yeah, let's hard code instead of, you know, doing a dynamic loop. But this is actually the best way of doing things. The most efficient way of doing things is to hard code. And so this may hurt your eyes, right? If you're a programmer, but it is the way to go about things, unfortunately. And you may say, oh, the compiler will just optimize that anyway, but I don't necessarily trust the compiler 100%, right? I don't really trust the compiler 100%. and my my goal is to make a game engine or a chess engine that's much better than my last chess engine, you know. So so if I want to do that, then every time you hardcode, a CS professor dies inside. Yeah, I know. I mean, it's me too. Like, it's totally my instinct to just create a dynamic loop to some, you know, defined constant that, you know, we switch color based on some variable. It, you know, it makes sense. That's my instinct, but, you know, that's also, but this is like the thing that I love about chess engines, is that it's often a completely different type of programming that you have to do, you know, with all this bitwise math and stuff. It's the it's the part of it that I also love, you know, is these, you know, since this gets run so many times a second, we really have to eliminate branching. And so this is something that I also want to change here, right? The annoying thing is our rank masks our promotion rank, right? We switch on side to do this. And so instead of doing the switch there, what we will literally you probably just want this to be a const, actually. Yeah, so let's do that. So let's open this in a split and go to types.h and have this as a constant. That is just a copy of this. So promotion ranks for color max. Okay, so we will copy into that. That is in utils.c, has these rank masks, and this is the first rank. And so this is going to be, if we go here and we do, let's just put it right under it. So uint64t promotion ranks to color max, and it will have yeah, it's just going to be, it's going to be white first, which their promotion rank is here, is rank 8, and then it will be black. Okay. So that should work. So we eliminate the switch here, right? And now our pawn moves, we'll get the pointer to game pawn moves indexed by the side. And we will do the same thing with our captures. And our promotion rank will equal the promotion ranks indexed by side. Cool. If we want to do this even more efficient, we could just, since we only use promotion rank here, we could just directly do this and avoid having to copy this, because we don't actually need a separate mask since we're not editing it. Okay, so hopefully that's correct. We're not necessarily done with this code, because we of course have to do the capture logic that we talked about earlier, but we're not going to worry about that right now. this generate attack mask that takes an aside is going to be different. It's going to be different, I think. Actually, this is kind of annoying because now you kind of want our pieces to be indexed by side to avoid this branch. Am I making this too complicated? That's a good question. Am I making it too complicated? I mean, that's kind of what you want. If we're going full in on this design philosophy, then instead of having this, you want to have it by color max. And you want piece types to only have 6 instead of the 12, right? I wonder if this is faster. Also, I have decided that this is just going to be a uint64t, and we are going to just pop the bits off to determine our locations. Piece color types will be 6. Oh, you probably just want to be this piece types and then this is piece color types. But I'm kind of worried about where else is piece types. I don't see it anywhere in here. We have it in piece names, so this is going to be piece color types. If we do this. I'm still not sure if we are going to do this, but it certainly makes sense to index this by color because or does it? It depends what we want to optimize, right? Because how often are we looping through both colors? We often just loop through our own color, right? So it would technically be faster CPU-wise if we have all of our colors contiguous in memory. All of our pieces for one color contiguous in memory, right? And this would avoid this branch here. It would avoid this branch. Of course, you could also just make a generate attack mask black generated, but that would end up branching at some point. So we could avoid this branch, right? If we do this entirely. Okay, so let's try to do this. Let's try to do this. It's certainly not, you know, a simple change for us to make, but this is, you know, this is what it is. Okay, so let's give it a shot. Okay, so game board pieces side, okay. All of the both pieces are going to be right. So let's go to game both pieces and let's change both pieces to board pieces both. Okay. Also, this piece count is going to be completely changed, right? We're gonna pop them off one by one, but for now, let's not even worry about that. Let's just go to game pawn captures with side, and then all of this we are just going to index this by this, and oh yeah, pieces is going to have to go by side. This function, by the way, what this function does is it generates a mask for all of a player's attack squares. And believe it or not, this is actually only done for the enemy, because what you want to see is if they are attacking any squares in terms of the castling squares. You can also do this to determine, to early figure out any illegal king moves. We'll implement that today as well. But anyway, so first thing we need to change here is we need to get rid of this, and we are going to do a uint64t. There's multiple ways I've been thinking about doing this. Is like piece count. If we're looping over piece count, unfortunately, it's actually going to be more inefficient than if we just pop the bits off one by one. At least my thinking is, because if we're using these pawn data, etc., knight data locations, what's going to end up happening is these arrays are going to end up with empty space, and we're going to have to search through them. For example, if we have a rook at a certain location that gets captured, then we're going to have to remove that location from locations, and that's inefficient. Another design philosophy I was thinking of is having an array of 64 that just has piece types enums at each square. And this is generated simply once every board state, that we go through and we pop the bits off and find their locations. I feel like that might actually end up being efficient, because that's what we're going to actually end up doing here, right? Like if I do this, right, and we get our pieces for pawns, the way we're gonna have to figure out what every pawn is attacking is literally finding the location of each pawn bit that's set to 1, which we have to use int pawn count equals bit count the pawns, and then what we have to do is loop through this pawn count and then pop MSB. This ends up pop MSB. You set pawns equal to pop MSB of the pawns, and then you have int index that you're passing through here that gives you the location of each pawn, and then that is what you use instead of the locations here. This is what it's going to look like here. And I'm unsure how slow this actually is. But the thing is, in my thinking about it, is if we are going to have to do this, right, which we technically do to find all of our pre-computed bit masks for every location, wouldn't it just be better to just do this once every position? Like before we generate the moves for a position, just literally do this and initialize the position of each pawn. And therefore, we don't have to do this multiple times. We just do this once. And then when a pawn goes to capture or whatever, it goes to capture, we know what piece is already at that position. So that's what I'm thinking. I don't know. I don't know what we think. What do we think? Maybe I'm thinking way too hard about it. I don't know. It's funny because this is move generation. This is like by far the easiest part of a chess engine, by the way. But I think that it's important to get move generation very efficient because it's the foundation for everything, you know? I also did read on some website that I did read that this guy was just his pawns, instead of pre-computing these bit boards, literally what he does is he just shifts the bits of each pawn, right? Is he just has all of his pawns and he generates this attack mask on the fly. Instead of just doing this, what he does is he just does attack squares ordered with the pawns it shifted over by 8, right? And this is a branch, right? You have a switch on side and you have a case black or whatever, and then you just have this in here, and this is basically this isn't for pawns, right? This would have to be like a king, right? Because it moves in one direction. Or this wouldn't be the attacks, it would be the moves for pawns, is that it goes up one. However, I think that there's extra branching here because you have to, for example, if a pawn is on its starting rank, it can move also 16, right? This is actually kind of what my first chess engine looked like. Was we had this logic that says, oh, if we're on a certain rank, we need to also shift up 16. And I think it just ends up being slower than if we just pop the bits off and work with the indices. But at this point, I mean, wouldn't it just be more efficient to just maintain 64 squares of information and just when you capture a piece, just set it to none, I'm not sure. I'm really not sure. I feel like this would be like a hybrid approach with both bit boards and a mailbox in one, So I'm not really sure. I'm not really sure. I'm not really sure. Because every time you make a move, we would have to maintain it. So if we decide to move pieces and we toggle the bit and we set the bit, and then we do this capture logic for the capture color, what we'd have to do is we would have to basically say, board at the move dot end index equals piece none, and then board at the move dot start index equals piece none. Or I mean, this would be, and then this would be, you know, whatever, like white knight or whatever, you know, it would be move dot piece. This has to be fairly fast, right? This has to be like a fairly fast operation, no? So maybe we do a hybrid approach, no? So that we don't have to do all this bit count pop MSB stuff. Instead, we just maintain a mailbox. We use bit boards to determine moves and captures and stuff, but no, you know what? No. You know why? Because if you have an array of 64, you still don't know where you're starting from. Because you'd have to search for that information. You would still need an array of all of your pawn locations, and maintaining that would be inefficient. So it's better just to have this. Just to do this. Yeah. Yeah. Okay, you know what? So let's just do this for now. And if we find a better way to do it later, then that is what it is, right? But just for now, let's just do this the way it is. You know, I do feel, you know, weird about, I do feel weird about, I don't know. I do hope that, I hope that, you know, people that watch my my game engine content don't get, you know, aren't upset that I'm doing the chess engine, I guess, you know, right now. But as I said previously, I got to a point with it recently where I just was really bummed out about it, you know, about the structure of my engine. So, you know. Oh, this is the index. Whoops. Okay. Hopefully we don't run into bugs with this refactor we're doing. Have a suspicion that we will. Okay. Make sure that we're changing to rook count. Okay, and then we have to do this for queen. Okay, is this good? Okay, hopefully that I did this correct. For now, we aren't going to worry about maintaining this information, I think. Though we probably should end up maintaining this information, but whatever. I'm surprised. Oh no, we do have 20 arrows here. I was like, I'm surprised we don't have more arrows. But yeah, we do. Oh yeah, we have to go. We have to. This is what we just wrote, and now we have to refactor it. Fun. Oh, let's just actually just get rid of the white because that'll be easier. Okay, that was painful. Not gonna lie, that was pretty painful. Okay. Wait, hold on. So there's this switch here that we want to avoid if possible. But I think we can. Actually, can we? To avoid this branch, what we'd have to do is separate the color from this. Inside of our move, we would have to have a color. But it would, I think we could avoid the branch entirely. God, I hate min-maxing software. Hold on. So castle flags does go by color max to castle side max. So yeah, we should try and avoid the branch here. The issue with that is that our move is going to have to change. We're instead going to have to go to piece type. And then have here side, move side. And our move struct is getting a bit big, which I'm worried about, but I think let's not worry about the size of it. I think that the size of it doesn't matter memory-wise. Like, it's not something that we should be concerned about. We should be concerned about branching. So that's what we're trying to eliminate here. So we don't want to be switching on color. We instead just want one logic for all of it. And so our potential captures will go to game board pieces indexed by the opposite side. Something that we could do, right, is we have our side, and then we could have a side, other side equals how do I do this? It's either 0 or 1. So can't I just do... What is not side? What does this give us? Maybe that works. So potential captures will be other side. And then game board pieces side. And then we are going to generate an attack mask for other side. And then if game, this is going to be castle flags indexed by our side. And we are doing the queen side. Okay, if our attack mask and this queen side mask, which we can get by it's game, no, it's just a global. It's castle masks indexed by side, which is our current side, and queen side. I think that this is both, right? Yeah. Both, and the occupation mask. The occupation mask, by the way, is the spaces in between the king and the rook. And the castle mask includes the king space, because we want to also make sure the king can also not be attacked, right? So we check, is anything in there attacked, and is there nothing in between? That's what the logic is. Okay, so once again, we are going to have a piece king, and instead here we will have a side, a move side, equals side. Right? And that's that. That's the move that we're gonna push. Let's clean this up a bit because it does look a bit cramped. Okay, well, I think that this just looks ugly and it's going to have to be ugly. Yeah, I don't know how to make it not ugly, to be honest. It just is going to look ugly. Sorry. Okay. And here I thought we would be getting to perf today. We probably will, to be fair. We probably will. We technically don't need our capture side because it's always going to be the opposite of our current side, actually. So we can get rid of that in here, I think. We can just do not move side if we ever need that information. Okay, so hopefully this works like I want it to. Okay, so that's our castling refactored. Now, this whole start for side thing needs to change. Something else that's interesting is we don't actually have to loop or have switch cases for any of this. The reason why I defaulted to that was just because that was the old structure for my engine, for, you know, my last engine, was that I had a loop and a switch case that just handled all of the pieces. But this isn't necessary at all. We can literally just hard code it for our sides now. So instead of passing black rook, what we should pass is instead just a side argument for black. How does generate sliding piece moves work again? I forgot. That's gonna matter. I forgot how it works with this with the arguments that we pass in. Right, so it binds this callback function. Really, you know what we could do? We could just make this 3 different functions, and even get rid of the callbacks. And that's what I'm gonna do. Just make a generate rook move, generate, you know. So I know that seems super, you know, copying code and all that, but it will be good, I promise. Okay, so this move list move count is still here. This piece data pointer piece data isn't a thing anymore. The piece doesn't matter. The potential captures matter. Own pieces matter. The reason is we want to avoid any extra code, like, finding our potential captures or our own pieces. This is masks that we already decide up here, potential captures and own pieces. So we just pass that in here. Our piece type of piece type is not important since this is its own function, and our blockers the blockers do matter because it's both. Okay. So this is going to be generate, oh my gosh, the error is over my code, bro. Generate, let's do bishop moves. Okay, and this is going to do exactly what this does, but with the pop MSB stuff. And it will instead of using the function callback, it will just literally use fetch bishop moves. But yes, of course we're gonna have to follow the pattern here where we get int bishop count equals bit count. And we will get a uint64t bishops equals our game pieces indexed by side, which we are going to have to take in as an argument. Let's take it in here, side, indexed by bishop. And we are going to bit count the bishop's mask, and then we will set that to the bishop count. And then we will, our int index will be 0, and we'll do the pop MSB thing. Bishops equals pop MSB with bishops and a pointer to that index. And the rest should be the same. Except it won't be the same. Piece will equal bishop always. And this is move side. Actually, we should just do side here. It should just be called side, and so I'm going to change that inside of here. And so we can go back and replace all of this. Sorry, there's a lot of, going back and forth here with how I want to do things, but it will hopefully save us some trouble later. Okay, so, okay. Okay, so something that we wanted to do is, of course, figure out what piece we're capturing, what piece type we're capturing beforehand, like I said. Damn, you hella smart, man. I don't know about that. So if we have check bit at the potential captures, I think that we just go straight into the loop to figure out what piece we're capturing. The other way of unrolling this loop that I was thinking about, right, is you get this move mask, right? And so instead of looping through and bit counting the moves, what we literally could do is our uint64t captures, and we could just do what we do already, is going to be moves and potential captures, right? And then our move mask will, first of all, moves, and then you XOR it with, this is the pattern we did earlier, moves and our own pieces. What this is doing is we find the overlap between our potential moves and our own pieces, and then we XOR it so that we get rid of all of those bits, right? Okay, so then captures is our moves and our potential captures. We want to do the same thing here and remove those moves. So moves, actually there's a simpler way to do this, right? If you just do yeah, if you just do moves in both pieces, it removes them. Yeah. And now we have our captures separate from our moves. And so instead of going bit by bit, we can just loop through all of our piece types. And then this is going to be piece types, which should be 6, right? You've never used XOR ever? It's important here when we're working with all these bitboards for sure. XOR is exclusive OR, which means it's basically, you know how OR would give you both, you know? Exclusive OR just basically if something, you get it. Yeah, it is strange syntax. So we're going to loop through all of our piece types, and then let's just get a mask for it. So capture for type is going to equal our captures and the game pieces other side I, which is going to be our piece types. I think that this is fine. And then I guess if capture for type, then we do the bit count for it. Okay, and then we get this count, and then we just want to loop through the temp capture count, and we will use C for this. Okay, and here now we know which piece type it is, right? So now when we push our move, we know which piece we're capturing, which is what we wanted. So our piece is going to be a bishop, and our capture piece will equal whatever I is. Yes. And this index will be our... Right, we have to not only bit count, but we have to pop MSB. So we want capture for type equals the pop MSB with itself, and we also want this int end index to pass into this function capture for type end index, and this will be our end index. Okay, and that's our captures. Hopefully I did this correctly. We loop through all of our piece types for the opposite color, and for each one that we find overlap for, we push moves for capturing that piece type, right? Much more complicated than what we were doing before, but it gives us important information, which is the piece type that we are potentially capturing, right? Which we need. So now we have our temp move count, and we don't have to check against our own pieces anymore. All we have to do is pop them off and push the moves, because we already know that they are valid. Okay. Hopefully this makes sense. I think it makes sense to me. And we want to get rid of all of this older stuff. You know, I think I'm just going to comment this out for now, because I kind of want it for reference in case we regret the changes that we're making right now. But yeah, so this is... How do I approach an idea? Well, that's a deep question. I don't really try and think too, like, you know, logically, I guess, about, like, you know, if an idea is good or bad. I just try to think about, like right now, for example, where I have different functions for generating rook, bishop, etc. Even though I could make them one function, and in fact that's what this was. This was one function, and it had one branch here that just assigned a callback function pointer that fetches the moves, since we have different hashing for our sliding pieces for different types, right? And so that's why when it goes through this loop for the piece count, that's what it was doing. It was just calling that callback function that it binds at the beginning of the switch. But now my goal is to avoid all branching completely. So now I am simply just making 3 different functions instead of having that switch case. Do I think it's going to make the engine so much faster? Absolutely not. But the way I think about it is that I would always have thought, like, what if I did this? You know what I mean? And I would always, like, have it in the back of my mind, you know? If there's something like that where I feel like that about it, then I always have to do it. No matter if it's a, you know, an amazing idea or not, you know? You just have to do it, because if you didn't do it, then you would, you know, probably think, oh, my engine is shit, you know, later down the line. It's just peace of mind, you know? You gotta have peace of mind with whatever you're working with. That's, but I'm probably not the best person to, you know, give you coding advice. My shit is super, janky. Most people would not be doing what I'm doing right now. Most people would just be like, you know, I think most programmers like shoving everything into one function, you know, and that's what my first chess engine looked like, right? Is move generation was a loop, right? That just looped through all the different piece types and executed different code for each piece type. But if you think about it, that's 12 if statements per move generation loop. And if we go over here, we can see that Stockfish at this position, 5 moves forward, finds 4 million moves. 4 million moves, right? And so the typical move generation loop finds anything between like 30 something to 80 possible moves, right? So let's just divide this by 30 to 80, right? And that's still, you end up with like, what is this, like 40 something thousand times. And by the way, it does this I'm going to show you how fast it is. Let's go perf 6. It does it that fast. And this is 119 million moves it's found. In how fast was that? Like 3-4 seconds. So most programmers would do this loop, right, with all the switch case branching, right? Fortunately, I'm not most programmers, you know. I definitely care about, you know, since I made my game engine, I've cared more and more about the little things, you know. So even if it takes a bit of sitting here and refactoring and writing redundant code, frankly, I don't give a shit. I'd rather have the peace of mind that I did it correctly, you know. But that's the way I was taught in school, right? To reuse code and make things as kind of uniformly, you know, don't copy and paste, don't hard code, you know. Every coding professor will tell you the same thing. However, what I've found is that there's no solution that is faster than hard coding. It is, if you know exactly what you need, right? Because you're telling the CPU exactly what to do all the time, without any if statements, without any, you know. So, yeah. But, yeah. So, now we don't have to generate sliding piece moves, we have generate bishop moves. And we have to figure out what we're passing in here. We're passing in a side, which is going to be black, the potential captures, the own pieces, and the blockers. So just this. Cool. And then we're going to do this for rooks and queens. Okay, so hopefully that this is a efficient way of doing this. Of course, there is some nested looping here. You know, we bit count our queens, we pop them off, and then we loop through, and we find the captures for each type, and then we push those moves. This isn't the fastest probably way of doing things in general, but it's the way that I can conceivably think of doing it the fastest. So that's the way I'm going to do it. Okay. So our pawn moves are next to fix. Oh, believe it or not, we only have a few errors left. That's actually really cool. Yeah, so we're gonna have to go through and do all of this. I want to check our pawns though, because our pawns are our most complicated stuff because of all the en passant promotion bit stuff that's happening. We want now this logic to kind of match this. Okay, so we got our move mask. Logically, I'm trying to think through an error tab. Yeah, you go through, it's space D on Helix, which is kind of, it's very helpful. Okay, so we get our move mask, and then we XOR it with our moves and own pieces with the potential captures. Which can just be simplified, by the way, to just our game board pieces. Both. That's what that variable is. Okay. Then we set the en passant. We do the captures with pawn captures at a certain index, and it with the potential captures. And then there's also maybe an argument to be made. No, there isn't, because you already get this index. Okay, the locations matter. Okay, got it, the locations matter, because we are going to be popping MSB for all of this. So this is going to be UN64T. Pawns is going to equal the game pawn, the game pieces side pawn, and we're going to int count equal int pawn count equal bit count pawns, and we will loop through that count, and then the index will equal 0, and we will pass that into the pop MSB. I was seeing this, I got this in my recommended last night, this guy who is coding a compiler, I guess. Young guy, he must be like 18, 19, and I just thought it was so crazy. I don't know. When people come in here and say like, oh my gosh, you're so smart or whatever, it's like, no, that guy's fucking smart. Yeah, till he gets a compiler job. Yeah, exactly, that guy. Yeah, I got people in here all the time that are like, dude, how do you learn to get so good at coding? You know, it's like, dude, like, I mean, I don't know. That guy was like, fucking doing some, I forget what it was, like tree something. I didn't understand it. I didn't understand it. Maybe it's just like a different, you know, thing that once you learn about it, it's not It's not that big of a deal, but yeah, I don't know. But I'm one of them, really? I don't know. I don't know. Maybe it is. I feel like that it's that thing with everything, though. Like, if you knew about chess programming, you would probably know a better way of doing this, you know? Maybe it's like that with everything. Okay, so our captures are masked with our potential captures, and then we AND it with the en passant, and then our promotion, oh my god, this is so complicated logically. Our promotions is our moves or captures, and promotion ranks for the side. And then our captures, we remove the promotions from the captures. Oh, right, so this is the interesting thing, right? So our en passant, we don't have to remove our en passant from our captures, because you would never have the en passant on your capture mask, because the en passant square is special. Yeah, that makes sense. Okay. So I think that this is good. But just like over here, we need to figure out the capture types. So we are going to do, we can do our captures, I think, logically before our moves. And we don't really care about bit counting our captures, do we? We don't actually even care about, do we? Oh no, we do. We do care. We do care. Okay. But we're not going, we don't actually have to bit count here, because we're going to loop through all of our piece types here. And then loop through inside of here per piece type. Okay. So it's going to be literally the same code, I think. So we could probably make a function for that, but I mean, it's just kind of pointless, I guess, if we're only doing it a couple of times. Okay, so for all of our piece types, capture for type is going to be our captures, and the game piece is not side I. And then if we find a capture, then we take that mask and we pop MSB for it. And this is going to be for pawn. And the capture piece type will be I. Yeah. Okay. Seems good to me. And this will be pawn move, of course. And this will be pawn. And then we have all of our promotions here, where we just push all of these moves at once. I remember I used to be so weird with this. Like, I had a push move that took in all of the arguments, and then it called another function that that did all of this if else bullshit that, like, finds if it's a promotion move, we need to do this and that, and it was so inefficient looking back. It's like just so simple to do these things, right? If en passant, just push the en passant move. Like, it doesn't have to be that complicated. Got it. This is why I did not want to go back and look at the code. And so that's why I just started from scratch, because I know it would have driven me up a fucking wall. Okay. So same thing for our knights, except also for our pawns, we don't have to take in all these arguments anymore, do we? Our piece data doesn't matter because that isn't a thing anymore. Our side does matter. Let's put it at the same location as this one, just to stay nice and tidy here. Side, side. And piece obviously doesn't matter. So there we go. Okay. Now for our knight moves. We are trying to copy this. And so first of all, we have to figure out the count, just like we do here. What do you do if there's a library, which you could have used, but I didn't in a project? Good question. I mean, I don't typically use libraries, I guess. I don't typically use libraries unless it's something that that I would find tedious to implement myself. So, for example, when it comes to parsing things like JSON, right? I always use CJSON because it's just like such a fantastic, convenient thing, right? There are a lot of libraries that I refuse to use. Oh, what's up, Greatorial? There's a lot of libraries that I refuse to use. I refuse to use GLM. I refuse to use TinyGLTF, Tiny Object, file parsing. Reason being, I think that if a library, as far as I can tell, doesn't give you control and convenience, and gives you kind of like a watered down result than if you just implement it yourself, then there's no reason I would ever use a library. And that's what I think a lot of libraries do. Like GLM definitely does this with the way its math operations work, with the way its camera, matrix math works. It doesn't give you enough control. Like, for example, in my game engine, I have complete control over every value inside of the camera matrix. In fact, I do my own manipulation with how the FOV works inside of my engine with the camera matrix. As far as I'm aware, you can't really do that in GLM. Like, for example, threads and stuff for animating, maybe. Those ones that don't have an alternative. Exactly, yes. Maybe there's a way. Yeah, there is a way to implement things. I don't really use my animation system in my game engine is my own, right? I parse the files, the asset files, straight from Blender, right? And I get nodes, skins, bones, and animation data that I apply to all of the nodes. And basically the structure is when I load an asset in, I basically say, okay, we're going to have a slot with all of the animation node data, etc. And whenever I spawn in a new instance of that asset, I need to copy all of that data into that entity so that when that entity plays an animation, it's just, animating that entity's nodes, right? So that's completely my own implementation of it. But as far as like making animations, like animating myself in terms of like moving my models, bones and vertices around and all of that, that is incredibly complicated. That would be incredibly, incredibly complicated, right? So that's something that I use Blender for, right? So things like that. But in my engine, I've used my own, I made my own math library and things. For something like a chess engine, I don't want to seem like a snob about it, but if you use a library for a chess engine, it isn't a chess engine. I don't want to sound like a jerk or anything, but I've seen people online, right, that post on Reddit and things that they made a chess engine, and all it is it's a recursive wrapper over someone else's move generation routine, right? Is that they've used a library that generates all the moves for a given position, and all they do is they recursively just call this library to generate all the moves for them, right? They don't actually have any code inside of their engine that is generating moves. All the engine is an evaluation machine, right? In terms of selecting the best moves, right? But it's missing so much of what makes an engine an engine. That, in my opinion, is not an engine. It's not an engine at all. I don't want to sound like a jerk, but anyway. I think if you're going to make an engine, then you've got to kind of accept what makes an engine special, which is the kind of like the handcrafted part of it, There's an art to it that you have to respect, and if you're going to take shortcuts, then you're just, in my opinion, you're going to miss out on it completely. You're going to miss out on it completely. But I mean, I don't know. I'm a very strange person. I'm sitting here with an incredibly long, beard, saying this, I'm basically a caveman at this point. Okay. So this obviously we want to get our knights. How long? Dumbledore? It's getting to Dumbledore, actually. I'd have to measure it. I kind of wanted to... I don't have a webcam, or I do have a webcam, but I don't have enough USB ports. But, it's pretty long. It's gotta be like, maybe 3 inches down from my chin, maybe 4. I read somewhere that all engine developers have beards, and I think that that's a piece of pride. That yeah, I like having a beard. Other people don't like it, I guess. They think it makes me look I don't know. Whatever, I guess, that, older or whatever, I don't know. I don't like not having a beard. It makes me look like a kid. Okay. So our knights are actually just going to be very simple. We, of course, are going to follow the same exact thing with our captures types. Why do we have an error when I do that? Why do I have this temp move count? Oh, it's just getting mad because I didn't delete this. Okay, and our piece is going to be night. Okay. Hopefully that this code is just works fine. Maybe I should have just made this a function. To be honest, I probably should just make it a function and like not. So let's just have find and push captures. And let's just write a comment that explains that this finds which piece we are capturing and then pushes it to the move list. And this can take in game pointer game. The move list, we have to make it defined for the amount, but whatever. Move count, it will take in the side, and it will take in our piece type for us. It will also take in what else do we need? We don't need anything else, right? Yeah, I think that this is fine. So this is just going to do this so that we don't have to keep copying and pasting the code. I think that this should just be it. Oh yeah. So it is going to need to take in the capture mask that we generate. And also the start position. Start index, I will call it. And then the piece will go to piece type. Okay, so find and push captures should just do it. And therefore we can eliminate a bunch of code here. So this is going to be just find and push captures, game, move list, move count, side, bishop, captures, and the index. Okay, cool. And we can just do that for all of the things going down. So this is going to be rook, ideas on like AI Hunger Games? What does that mean? You deleted your message. Intrusive thoughts? Like between different AIs? Hunger Games between different AIs? That's crazy. Okay, so for pawns, this is going to be it. Hopefully. Okay, so that's that. For knights, hopefully there's no issue that I'm going to figure out later with what I'm doing here. Okay, so hopefully I'm doing this correctly and etc. So these are our kings. Okay. So for our king moves, we can also get rid of a bunch of this stuff, like our piece data and our piece. since, we are just going to do the whole pushing bits again. Like AI run simulation, and they have like facade and emotions of plans to survive the Hunger Games. That sounds like you are cooking. Because I feel like the Hunger Games would be pretty entertaining, you know, if real lives weren't on the line, you know. That might be a cook right there. Now, the reason why this isn't going to be super efficient is because we do have to copy these integers all the time, which is kind of, you know, silly, because kings equals kings, basically, you know. This isn't the most, really the most efficient way of doing this, you know, but I can't think of a better way. But maybe if we just didn't have these pre-computed masks and we were instead just bit shifting, it would be faster, but I don't know. Okay, I have no clue if this is working, but that is kind of everything refactored into the thing. So we have to do this changing here. So we are just going to pass inside potential captures and then get rid of this. I think that that's that. And then the knight and king moves should just look exactly the same. Okay, well this looks pretty clean. We can just put them in order here by value. So that would be pawn, knight, bishop, rook, queen, king. Okay, I'm assuming that we have some errors in other parts of our engine, which we do. Inside of this make move function, we have issues. Inside of our fen, we also have some issues. And yeah. All right, peace out, Sleepy. Thank you for stopping by. Yeah, so we do have some errors that we have to run through in other files. So this is an issue here. We also never put this into a variable. We never actually put this into we have to put this into arrays called castle masks. Is it? Yeah, I think it's that. So this is going to be like it's going to be the white masks before the black masks, right? So it's going to look like this. And then it's going to go by castle side, which I'm pretty sure in our enum is queen side and then king side. So if I'm correct, it's black before white. So let's just do this, black queen side. Okay, well I wish that didn't do that, to be honest, but it is what it is. and then black king side. Now the formatting is kind of annoying, but whatever. And then we just want to get white queenside mask, and then just replace that. Okay, I kind of spaced out, so hopefully I did that correctly. I'm not really sure. Now we need to do the castle occupation masks, which are the same thing. Well, similar. Okay, so it's gonna be the same pattern. Did I just put, no I didn't. I got the right thing. I've got to really use this GW more. Okay, hopefully that this is the correct masks. And we can just get rid of this, hopefully. Hopefully I did all that correct. Okay, so if, now we don't need to do that anymore. If check bit, well, this is going to go through, piece color types. It's gonna have to be a nested loop. Oh, wait, hold on. It's not piece color types, it is piece types. Whoops. God, I got really sidetracked today. I was not expecting it to be like this. Okay, so hopefully that is correct for printing the game board. Yeah, I'm not sure. Some of this stuff is probably wrong now, but whatever. For now, it's fine. So make move, let's just comment this out since this isn't, we haven't even touched this yet in terms of, okay, so when we do our fen, obviously our game castle flags for white kingside. It's gonna be this pattern. Okay. Set piece. This is going to take in just a UN64T pointer to the board. Probably wrong in here, huh? No, it isn't. It's just telling me that that we're here is wrong. Isn't it supposed to be this, though? Maybe not. That is weird, isn't it? That is not a pointer. Weird. What is this, this function? Is, temp mask equals pop MSB for the temp mask. The piece data for the board for all of our pieces. And we go through our locations. Okay. So set piece should just do it. This shouldn't even be a thing. Yeah, I'm hoping that this set piece works. Okay, let me just try and compile this. I'm not really sure. Okay. Okay, we have some issues, of course. A big issue all of a sudden seems that we only have white pawns. All of our pawns are also white, but we don't have any pieces that aren't white pawns. So I'm going to assume multiple things are happening here. This is not obviously the correct side, which is something right there. But first and foremost, we are not setting up the pieces correct. So there's that. So set board to fen is no longer working. Either that or the printout for it isn't working, which we can also check. So let's wait, actually that's totally true, because game pieces is supposed to be indexed by, that's why it's supposed to do the color. Oh, but we don't. Oh, interesting. Piece equals parse piece gives us a piece with a but not the color. Or the color isn't unwrapped. Honestly, since we only do this, when are we getting the interface? Soon. I have to, you know, work on all the architecture first and then move generation. So how do we want to do this when we parse the piece? We need to get, well, we do have the color. You know, we could just do it like hard-coded like this. So if the piece modulus 2 is 0, else. So if the piece modulus 2 is 0, then that will be black. And that's a pointer. Except we're not indexing it by piece. We're indexing it by... Oh my gosh, that's so annoying. We have to make another utility here, I think. And what we're going to do is we will... let's make a utility that literally just does piece to piece type and color. And this is going to unrolls piece enum to its piece type and color separately. And this is going to take in the piece, and it will have what's happening. So we did a bunch of refactoring to avoid branching in the engine. Now our pieces and our piece data is separate by color. So instead of having all these switch cases based on black or white, we have our arrays all separated by color, and therefore we just index into it, right? The issue with this is now our parsing string logic needs to also match this convention. So piece type is the type without the color, and piece it has this, right? So we need a function that swaps it. So do I have anything that just does this? Oh my god. I think I got rid of all of it. Maybe there's a way for me to just like do this and then copy it into there and then just reformat it. After this, hopefully there are minimal issues with the refactor. Let's just go here. Nice. That was cool. That was very cool, what we just did there. Very cool. That's what the pattern is going to look like, and if, let's just have it if not piece type. There we go. So that's what the pattern will look like. Maybe it's just faster to literally do this and then just copy it down and then change the piece type. I think that that's the fastest way of doing this. Oh gosh. I hate it in Helix when you press U instead of I. They're right next to each other and they do incredibly different things. One undoes what you just did and one inserts new stuff. So sometimes instead of inserting new stuff, you just undo what you just did. Oh gosh. Wait, what? Wait, am I off here? Black, white, black, white, black, white, black, white, black, white. Okay. I was missing one, that's fine. Okay, so let's put this in the header file. And this is what we will do here, is that we will use this. We will get a piece type. Converted type. And we will just call piece to piece type in color with our piece, and at piece type, our converted type. And that's what we will do, side and converted type. There we go. Okay, so let's see if this works. And there we go, that's our board. Let us check to make sure that this is the correct board. 2b5. Okay, so this is a knight instead of a bishop. Interesting. PPP 1N NPP. Okay, so our piece types are incorrect. Okay, let's take a look at our enums. Pieces to piece types, which is 6. And our piece types go pawn, knight, bishop, rook, queen, king. Wait a second. Did I... White bishop to bishop, black rook to rook, black knight to knight, piece type knight. Black pawn to pawn, pawn. Pawn, pawn, knight, knight. As far as I'm aware here, we didn't... I'm wondering if our printout for the board is wrong. And this is correct now. So let's go to where that is, which is in utils. This is inside of print game board. Piece names indexed by P, that's why. It is an index by P. That's why we're just printing it out wrong. And how we fix this is we once again call this piece to piece type in color, I'm pretty sure. Or no, we have to go the opposite way. We have to go piece type and color to piece. So this is going to take in a piece type and a side. And this is going to do the exact opposite of this. First, it's going to switch on side. Okay, now this is going to be annoying. So this could probably be done a lot simpler. The indenting is fucked. Don't worry about it. Don't worry about it. Don't worry about it. Don't worry about it. Don't worry about it at all. It's all under control. It's all under control. Maybe we shouldn't be doing it this way. Maybe we... The good thing about all of this, though, is that all of this stuff is only happening basically for debug purposes, you know, like for how we display information, how we take in information into the engine. None of this is actually happening during move generation time, or, you know, during where we're actually doing anything important, right? Okay, so this is going to take in the P and the C. Where are we mad? Oh, yeah, this is piece type. There we go. Hopefully that fixes our issue. Okay. And this becomes a white bishop now. And everything seems correct. Cool. Okay. Now we have an issue with our promotion moves again. It seems like we are getting everything but our promotion moves from this position. So let's go look at that, which is going to be in our move generation for our generate pawn moves. We probably have a typo here. Did we touch this? Is our moves... Moves ORed with captures and our promotion ranks for our side. Okay. Let me go take a look at what about promotion ranks for the other side. Let me see if this is... Okay, that's what it is. Our promotion ranks are backwards. We swap them. So now we should be able to go to promotion ranks for our side, and it should give us 44, which is the exact amount of moves from this position. Perfect. Okay, so now that we have all of this decided and squared away, now we can finally implement make move and make our first move, which is very exciting. Let me just get to this on my left split and then go to types with my right split, just so that we can pay attention to what's happening here. Okay. Hopefully we can keep our make move very, very simple. So we can get rid of this now. Our side to move pieces are going to be set to a pointer to our game board pieces for our side. We will get rid of this. Our piece move pieces are moved at piece, which isn't going to be the case anymore. It's going to take in our side and our piece. There we go. Move that piece. There we go. Okay, and then our other side pieces is just going to be not side. There we go. And our capture board, there's a reason for this starting at null. Okay, so start for side captures, we don't have to worry about this anymore. Okay, so for a generic move, which is just moving a piece to another square, we are, for our piece board, which is for that specific piece, we are toggling where we started and then setting where we end. And the same thing for our side to move pieces. And what we want to do at the end of this is to also do the same operation we want to do the same operation with our entire board. So this is going to be our game board pieces both. Is we're going to toggle bit for that board at the start index, and then set the bit at the end index. Okay. And then I thought about this other way of doing it, right? Where you XOR the set bit with the start index and the end index, but it actually ends up being the same amount of operations, I believe. So there's no point, I think. So hopefully I'm doing all of this correct. Okay, for captures, it's going to be a little bit more complicated, but hopefully not that complicated at all. Because all we have to do is do the same thing for the capture board, which is we will do, it's going to be game pieces indexed by not sides, so we're always capturing the other side's pieces, and we will take in the move dot capture piece, and then this will equal toggle bit for this board at our end index. And we are going to do the side to move pieces. This is the same thing as right, except we also need, of course, to do our other side pieces. We need to also toggle that same bit that we just toggled. At the end index there, and of course we are going to also do the okay, so this is where it gets a bit complicated. We need to we need to toggle only the bit for the square that we left. Actually, yeah, because capture is separate from en passant. So we will just toggle the bit at the start index because we already have a piece at the end index, right? Because we already did this. So yeah, because we are capturing a piece, so there was always a piece there. Okay. And that is our capture logic. Hopefully we're doing all of this correctly. I think, just to be absolutely clear, we should add some comments. So move piece on its board, move piece on its colors board. Also, this is the wrong its. And then we are going to move piece on the global color board. Okay, and for capture, move piece on its board. We will move captured, toggle captured piece on its board, move piece on its colors board, toggle captured piece on its colors board, Okay, there we go. Those are all of the operations we need to do when we execute a move. Okay. En passant is going to be similar to a capture, except we have to toggle a different bit than the space that we're moving to, of course. So, but it's similar to a capture, right? We will do the same thing here. We will do this not at the move end index, but the way I did this last time was I found the index, I either added it if it was black or subtracted it if it was white. I'm realizing that I probably don't actually need to do that, and I can just write a shifting thing. Yeah, but you still actually need to, yeah. Yeah, you are gonna still need a if statement here. God, trying to do this without an if statement is so interesting, but yeah, it's hard to do this without an if statement because you need to know which position. Right, and if you're toggling the white piece, then you're gonna go up 8 or down 8, and then if you're toggling the black piece, then you're going to go in the opposite direction, because the en passant square is the square that you're moving to, not that you're toggling, right? So you need to know which bit to toggle, I suppose. Actually, you don't. Actually, you don't. Actually, you don't. Because we already have this information in a mask. For a certain index. Okay, got it. So we aren't going to toggle at a certain index. Instead, what we'll use is we will index into that side's pre-computed move board. Because at the en passant square, they would always have a bit forward. And so we will toggle it by exclusive ORing with that board. So what this will look like, if I'm doing this correctly, we do exclusive OR with itself and that. Hold on, let me think. I don't think you need to and it. Hold on. No, because that and that would give it would give you it would just give you that one piece, and so it's the same result. So this would be game pawn moves, index by not side, and it's going to be at the en passant square, which in this case would be the move.end index. And we'll write a comment for this that explains what's happening here. This utilizes our pre-computed board masks for movement. The en passant square for each side wait, hold on. Yeah. Will always have one bit forward, which is the exact bit where our pawn that we are capturing is. We avoid having to check if black or white and just use this mask. Cool. I never came up with that solution when I made my last engine, so that's a neat solution right there. Okay, so we still want to move the piece on its colors board. This is also going to be the same thing as this. Okay. So we're gonna do the other side pieces here. And we are going to exclusive OR it with that, exactly that. Toggle with captured piece on its colors board using the above trick to find its location. Okay, and then we toggle move piece, start position on the global board. However, on both, we also need to toggle. In this case, hold on, let me write a note here for this. We don't need to touch the final location since it is at a bit. Okay, so this is going to have to change because now we need to toggle here. We need to do this. We need to toggle. We need to do that, right? We toggle the start, and then we will call set bit. Okay, so that is the logic for en passant. Okay. Now castles and promotions. Okay, so castle is going to be a bit weird since we do have to move 2 different pieces. But it shouldn't be that bad. What it looked like last time was you have a piece board, which is always and then you want to have the annoying thing here is that what I struggled with last time is that I always ended up with basically if statements here. So if our start is a certain number, it's super messy and it's slow. When we can do this, we can pre-compute this, or there has to be a way for us to do this simply. We already know that it's going to be a rook, so we don't have to worry about that. You know what we could just have here? We could just literally have a castle side. And yeah. And then that'll index into a global variable that has it. Yeah, that makes sense. Okay, so let's do this. Extern int extern int rook castle locations. And this we can do color max, castle side max 2. And it will be start and end. It's much faster than doing it during runtime, of course. So we can just hard code it to color max, castle side max 2. Okay, and then of course inside here we're going to have black, white, I like the lowercase. Bruh, zig or go. I don't really know. I'd probably choose go based on what I know. I don't know much about zig. I know that there's some cool like allocation stuff that you can do with like allocators in zig. I think. I mean, they're kind of like 2 different things, aren't they? You know? But, yeah. From what I know, though, I think that Go has a much more mature kind of build system than Zig. I couldn't really imagine building any sort of large project in in Zig, but in Go a lot of stuff is in Go. Okay, so these are going to be indices. So this is, I believe that we have, this is queen side, king side. Yeah. And these are just going to store the indices for where our rook starts during castling and where it ends up. So yeah, let's make sure that our, yeah, it is queen side and then king side. Okay, so let's think about the locations, right? So black has on queen side its rook at 0, and it is going braces around. Do I just do this? Yeah. Okay, so where does it go? I have to like think. I can pull it up in a thing on the Bitboard viewer website. So let me do that. Hopefully people aren't mad that I'm pinging in the Discord for doing these streams, even though they aren't game engine related. I hope that people aren't upset about that. But oh, is my internet bad right now, or is this site down? Okay, I'm not gonna worry about it. The site loaded. Okay. So I believe that this would go to 3. And if you want to see what I'm looking at this. This is the layout of my engine's convention, right? Is that you have this king at 4, it goes to 2. We have the rook here that goes over here. And so we're going to have a rook at 7 that ends up going, I believe that if it's I think that it goes here and then the king goes here. Yeah. I have to... Actually, you know what? Or does it go... Yeah, so the king ends up here. So this goes to here. Like 99% sure. It goes to 5. So we will go from 7 to 5. And then we'll find out later if that was incorrect. But that's what I think. That's what I think. That's what seems correct to me. Okay, and so then we have this rook down here. The king comes over to there, and then it ends up on the D file. So it's going to go from 56 to 59, if I'm correct. I know I messed this up on my last engine, and then I was like super confused. Okay, and then king side, it will go from 63 to 61. And then we will put a note here that this start and end locations for rooks during castling moves. And we will look this up really quickly. You know what we can also do is make an enum for start and end to be super clean with it. Start end. Which will just be 0 and 1, right? And then this is super neat because let's not worry about it. Okay. So now inside of make move, which is where we were before we went down this rabbit hole, we need to, figure out where our rook is going, which is what this was all about. So instead of using piece board, we are going to go into game. We will go into our pieces for our side, for our color, and it will always be a rook. We will toggle bit with its current board at this location that we just cached. Oh my gosh. Wanna put this down here. And we want to get that location that we just got. So this is under rook castle locations. And we are going to index into this using our side, the move.castle side, and we will use the, we will say start, right? Because we want to get the start position, and we will be toggling, oh yeah, so that's it. That's how we get the start position, and then we want to get the end position to set it. So we're gonna call set bit on that, and then we will say end. Okay, now let's make sure that castle side is what we want it to be. Castle side is correct. Okay, so before I forget, we have to go to move generation where we generate our castling moves, and I want to make sure that we include this information because we neglected to include it. So castle side equals queen side in this case, and this is king side here, and then we will just put this here. Okay, so that's our castling move. I think that that's just it. And what we have to do is we have to update the global board pieces now. So our side to move pieces, we want to do some bitwise operations to update that board. So we will toggle and set just like we do here for the king. And we need to toggle and set for the rook as well. Thanks, Unbreakable. You too. Have a good night. It's actually, I don't know, it's 3 o'clock here, so it's not really night yet, but yeah. It's getting there for sure. We also need to set it for the rook though. And so here I'm wondering, toggle bit is fine when we're just toggling and setting one bit, but what we probably should do here is in Turkey time it's 23:26. Wow, that's late. That's nearly midnight. Yeah, so there's probably a faster way to do this than just doing this 2 times, right? We could we could it would be something like side to move pieces, and then you OR it with 1 ULL shifted over by move.start index. XOR it. I wonder if this is faster. Manually shifting. Or not, I'm not sure. And then you can do side to move pieces, and then you OR it with one ULL shifted over by move.end index. There's also this way of thinking about it, where instead of toggling and setting bit, I think that this is 2 less operations. So this, this gets rid of the starts, and then ORs it with the end. And now I'm kind of thinking back to see if this would be faster if we did something similar here. We would still have to OR it and then we can write it out to see if it's faster, but this is just doing this internally. Right, it's toggle bit, just XORs it, right? So what it would end up looking like if we were to do this way would be, I think that this is actually faster. I think that this is 1 operation less. Because what this is doing is it gets a bit at our start index and a bit at our end, and then it just XORs it once. With this toggle and set bit, what we're doing is we're doing this, we XOR it once, and then we OR it here. Or is this the same thing? Is it the same exact thing? So we OR here, and then to toggle we XOR it. So we OR here, and then we XOR it here. So is there any difference in speed? Well, here we're only doing 1 pointer thing. So I mean, technically faster, technically. Just writing it out like this. So that's what I'm gonna do. we aren't going to fully commit to that on everything, but yeah. I'm probably making this way too complicated for no reason. Okay, so promotion. Promotion is interesting. Okay. So oh, okay. So here is what we need to change here. Promotion type should not have this. No. Because then we're going to have another branch. No, it should not be a... This should be a piece type. This should be a piece type 100% promotion type. Because we just want to index straight in. So in this case, we want to only... Our piece board is going to, we're just going to toggle the bit at the start location. Because we don't need to set it at the end since it's turning into a different piece, right? We also want to, of course, toggle it for the side to move. That's correct. But we need to go to game pieces, side, indexed by the move dot promotion type, and we want to set a bit for it. At the move.end index. Okay. And then... Yo, what's up, Luca? Good to see ya. I'm listening to soft ambient drones and programming a chess engine again because my last one sucked. Okay, that should be that. Of course, we also have to update the both board. Just like this. We're about to make our first move. I've been doing okay. I took a break from streaming, from programming things, really. I just got really bored of the engine, the game engine, to be honest. I just kind of, I don't know. My game engine, I think I got too good at it to the point where the game engine was just starting to become an asset viewer, you know? And I don't know. It just like, now my game engine just takes in, you know, a bunch of files and just draws it to the screen, you know, and animates things and all that. And it's like, I don't know. There's used to be so much like the map editor and all this stuff. Just, you know, it's all deprecated now because of all the scene nodes and all of the skin animation skins and all of this, you know. You can't really edit every single vertex, you know, anymore, which bums me out because that was kind of the cool thing of my engine. But I'm just taking a break to make something new because I think that, I don't know, I think that I can definitely make such a good chess engine, so much better now with being much better at programming than I was when I made my first one. So I want to see if I can make like a Grandmaster chess engine, you know. So when we promote, we are going to toggle at the start, and we will set at the end. The interesting thing actually about promotions is that they can actually also be captures. And so I didn't actually think about this. I didn't think about this. I didn't really, I forgot about that. Okay. So this is going to have a capture piece. The issue is we're going to have a switch anyway. So there's two ways of doing this, right? Inside of piece type, we could just have a thing here that says piece none, right? Which is how I did it last time. Absolutely not going to do it this time. The reason is because having an additional thing in your enum is never good design in my opinion. And you're still going to have an if statement here. So instead, what I'm just going to do is I'm just going to have a flag here that says bool promotion capture, and that's only in that case will we check for that. You're doing a chess engine, me studying a chess-based algorithm problem. What a coincidence! You're really what is it? I may have heard about it. I kind of know, about chess programming, given that I've, worked on a couple engines. So we do the set for the promotion, and now we have to have an if statement here. Unfortunately, we've avoided if statements pretty much in the entire engine so far, but so if move.promotion capture, we won't actually have an else here. If the move promotion capture, then we want to toggle the bit for that piece. So game pieces side move.capture piece is going to equal the we're going to toggle bits on that. At the end index. And queen's problem. Find how many possible queens can be on a board of n times n without getting in each other's way. That's interesting. Yeah, it is. That's definitely a backtracking algorithm. That's sick. Definitely some recursive fun. Is that for a project? At school? Side to move pieces, toggle bits. Okay, so then we are toggling our side to move pieces. We also, inside of promotion capture, we want to then go to our other side pieces, and we want to toggle that bit. Okay, if it's a promotion capture, then we go to what piece we're capturing, we toggle that bit, and we go to the entire other side pieces and we toggle that bit as well. Then we update our side to move pieces by toggling and setting, and then we update our board pieces. The thing is, we can't really update our board pieces Okay, so there will have to be some else action here. for exam at school, but recursion and fun. Recursion, trust me, chess engines are basically all recursion. You finally got a job? That's sick. That is sick. Was it the one that you were talking about last time? I forget what it was. That was a while ago now. So we can move this up here. It's going to be an ordering thing, I think. So we are going to toggle at the end. And if it isn't a promotion capture, then we will set the bit at the end. Otherwise, we're just going to keep that bit. So we don't need that operation otherwise. So if not capture, put a bit at the end. If a promotion capture, no need to change the n square since we are only replacing. Okay, and that should be hopefully the entirety of our make move function. You got a job as a system admin in telecommunications. That's awesome. A sysadmin? That's crazy. I don't really know what sysadmins do, but it always sounded cool. Like the job title. What's up, Kubki? How are you? So, my last engine, this capture board isn't a thing anymore. My last engine had a Boolean that this returned that basically said, is the move we made just a legal move? And if it returns false, it undoes this move, right? And I'm unsure if I want to follow that same philosophy or not again. It's hard to really remember what the ramifications of this were, but I remember having some trouble. Working at data centers, so it's really cool. I feel like messing with hardware and Unix systems. Yeah, that sounds really fun. That does sound like a lot of fun. I'm not sure. What we could also do is just return a Boolean and undo it from here. I'm not really sure. Okay, so let's put undo move above make move, which doesn't really make sense, but the reason why is because we may end up calling undo move from the make move. Undo move is way more complicated than make move. It's probably the most complicated part of an engine, is the undo function, because you have to do exactly the opposite of what you just did with the information that you have. And sometimes, especially when we get into transposition table hashing, you may run into issues if there's some edge case inside. So we have to make an undo move. What also we have to make is a void check if valid. I'm not naming this an incredibly correct thing, but this is going to be a function that checks if our board state is valid used to determine if a move we made is legal for pseudo-legal undoing. Okay, so we can take in our game pointer game, and inside of this we will check a couple of things. I think that the most important thing is oh man, glad to know you're having fun in a new project. I'm gonna have to head out to bed. All right, yeah. Thanks for hanging out. Hope that you have fun at your new job. That's sick. Peace out. So we're just gonna check if our king is in check, I think, honestly. Which, it's fine. Let's find the function that checks if attacked. Let me find this function. Is it inside of here? Check if attacked. Oh, I didn't have this. I just made an attack mask. Right, so we're doing this attack mask thing. I wonder if this attack mask thing even works, though. Because you could have, like, a discovered check on your king, right? That wasn't an attack before. So, yeah. So yeah, I think you have to generate a new attack mask. I think that that's the way you do it. But I mean, that seems like such a long process, but maybe that's the way you do it? I think that that's the way I did it last time. Was I basically generated an attack mask and then checked if our position was on it. Is it this simple? Is it this simple? I don't know if it's this simple. I don't know. Okay. So we now have a undo move to make, which I'm kind of dreading, to be honest. I think that we probably can just like copy and paste our make move, just very simply. I think last time I really overcomplicated things, but hopefully we can keep it very simple. And just reverse the changes. Hopefully this works just fine. It is a lot of code. It is a lot of code. It is a lot of code. Okay, it's gonna be similar though. Okay, so we need. Actually, we have the side on the move. I believe. We do. So we don't need to take that into the make move at all. Okay. Oh, also, we have to, here, we change the side to move. So game side to move equals not game side to move. Okay, and the same thing is going to happen in our undo move. Okay. So for a move, if we're undoing a move, do we just want to do this actually? This works fine, right? Because we are setting a bit at the start and a bit at the end, and then just toggling both of those bits. I think that that's fine. Side to move pieces, we're toggling the bit at the start, and we're setting the bit at the end. We want to do the opposite of this. In fact, this is probably where we can just like copy and paste this and just do this instead, because this works in the backwards direction as well. And we can do the same thing with this. Yeah. This looks correct to me. Now, every time we have this side to move pieces, we should just replace it with this. Okay. Since it works in both directions. Okay. So we are toggling the captured piece on its board when we capture, and this should still be a toggle. It should still be a toggle because we're turning it from off to on. But to be absolutely clear about it, we can just set bit. We can just set bit at the end, and we are toggling this. We should just go to set because that's more clear. And then now this is where things get a bit different, right? Because we want our board pieces to have not only the start index, but also the end. And so this is probably just a situation where you're gonna OR it with both the start and the end, right? Because you want it to have both of those bits. So this is a case where I would say this just goes to this. And hopefully I'm not crazy about that. Okay. These comments are going to be incorrect, but we can change that. Okay, so let's take a look at en passant. If I remember, undoing en passant is kind of weird. So once again, our piece board start and end should be fine. We do the capture piece Zord with the end index. But instead, let's just do this. Okay. Because we will just set that bit there. Yeah, I think so. And then the other side pieces, we want to do the same thing. And then we want to set bit to the start index. And then toggle captured pawn its found location, which is, it Zords it with the pawn moves. Right, so this is the OR. And the set move piece to its final location, we set it to the end. And in this case, we want to toggle it. So we're going to toggle bit at the end index because nothing should be there in the case of undoing an en passant. Nothing should be at the end index. Yes. Okay. So what I'm seeing here, this could be simplified even more if we just do this and then create one, and then we can optimize this even more, but I'm not going to worry about that just right now. And we could also simplify this down, I think. No. No, yeah. Okay. This looks okay to me, so I'm just going to assume that it is. Okay, so this is our basic move, so that should be fine. We're toggling both the start and the end. Then we are toggling the start to the end, and what we want to do is the opposite here. We could probably write that out in a better way, but let's just keep it like that. And then we change the side to move pieces. What I'm realizing is that we didn't actually change the both board here, so we have to do that. This is the start index to the... Okay, so this is fine. Okay, so we want to Zor this and OR this. Okay, that makes sense to me. Also, let's just do this before I forget that we have to update the full board here. How am I going to do that? I think we need to perform exactly this on the both board. Okay, so let's do that. So we're going to toggle the start and the end. We toggle the start and the end, or the start and the starts, both of the starts. And then, because we're moving two pieces, and then we set at the end. I suppose that you could cut an operation out here if you just OR it with the mask entirely now. Like, technically, you could just, like, do this, and then just have this here, and then just OR it once. I don't know if you have to wrap it all in parentheses, but that's what I'm going to do, just in case. But I think that you can just do that. And you could do the same for the side to move pieces. The good thing about coding this way is that it works in both directions. So we don't have to worry about it here, is that we can just do this. It should work in both directions. We are XORing it with a bunch of different bits and toggling all of them at once. And it should work in both directions. So that's that. And within our undo move here, we have to undo promotions. We can just toggle the start index, or we can set it to just make sure. Whoops. Set bit. And then game pieces, move promotion type. And then we're setting the bit at the end. For the promotion type, we want to toggle that off that board. So we're setting our piece at its start, we're toggling it at its end. We also want to unset it at the start. So we're just going to do exactly this because that's what we want. Toggle it at the start, toggle it at the end. And do the same for the side to move pieces. And then game board pieces, both we are toggling at the start index. But instead we want to do exactly this. Yeah. Okay. If we are capturing a piece, then we need to set that captured piece back. So then in that case, we shouldn't do this yet. We shouldn't do that yet. Let's not worry about that yet. So the capture piece we're toggling, we can set bits at the end now. And then we want to set bit on the other side pieces, and then how do we want to update the board in this case? For the board in this case, the board with both, we want to OR it with, because we want to include the changes above as well, not just in the if statement. We want both at the start and the end, right? But in this case, we don't need anything at the end. We just need to set the bit at the start, because the bit will already be... Hold on. In this case, you actually want to XOR this to toggle it, right? Yeah. And if it's a capture, then you want to place both the bit back at the start and the bit at the end. Yeah. Yep. Okay, I have no clue if this this works. It's a lot of code. It is a lot of code. Okay, no clue if it works. So only one way to test it, right? But before we do, I want to kind of make sure that I have no clue how to test it, really. With that, whatever. We won't worry about it. So what we can do is we can take in a string for performing a move, which is what I'm now going to implement, I think. So let me okay. Okay, so let's... The way I did this, previously is with scanf, but I know that it isn't incredibly safe. I think I might try fgets this time. I'm trying to see how to use it though. Okay, yeah, got it. Okay, so the file argument is just stdin. Got it, got it, got it. So then let's make a loop here. That is going to get our input. Okay, so let's do let's just do this for now. And we can take in our game and should I do this in main? Yeah, it's probably fine to do this in main. Update blocker masks. Let me see this. Let's just only call update blocker masks inside of an init game from fan. Let's just update blocker masks inside of here. Actually, it should be inside of set board to fan, to be honest. Okay. We'll stop printing out the game board, and outside of init, what we will do is, instead of calling generate move straight up, what we'll do is we'll have a while loop, and we'll just have a global variable called int running, which is what I typically do. And if we init properly, what we'll do is running is 1. And then while running, we will call handle input with our game. And our game, we have to put this in the header file. Okay, and this handle input will take in our string. So I'm just going to use you know, it's just going to be a typical CLI, you know, thing. So we're going to use fgets to do it. And it will be input line to, do you do 100 or do you do 99? Oh, you can just do size of. What's wrong with me? I have problems. Size of input line, and we are going to use stdin. Okay. And we will then switch on, well, we can't switch on the input line actually. We have to parse it, I guess. How do you, okay, so we're gonna do stir talk, right? And then this is going to be a char pointer that we get back, right? Don't you have to do this in a while loop? Let me look this up. I always forget how to do this. Yeah. Yeah, so this is a while. Oh gosh, please don't tell me I'm lagging. I'm not lagging. I'm not lagging, you're lagging. Okay, I'm kind of lagging. Okay. So this gives me a pointer to the character, right? Or does it just... Wait, hold on a second. I have to re-look that up because I just forgot what I read. Right, you pass in null the second time. Okay. So and I guess we want to parse this in the way that if we're just going to run string compare with L against move. And if move, then we want to actually, no, you don't. This looks a bit weird, but we need the first to specify the mode, I guess. And I guess we can have an enum that deals with the command type, I guess. And this will have inside of it move. Oh. Command move. Command perft. We don't really know. Okay. Oh gosh, please don't lag. My keyboard sound is very ASMR. Thank you. That was my intention with it, with building it. That I've had it for about 5 years. So we want to set command equals command move. And the reason why we're doing it like this is because then we can switch a switch case afterwards when we're taking in additional arguments. Maybe this isn't the best way of doing this, but it's the way that I think we should do it. Okay, so while we still have things after the space, what we want to do is, my stream pops up randomly in your feed. That's sick. I know that since I've been doing my chess engine kind of series of streams, I haven't really been getting a ton of new people, so I'm glad that it's kind of hitting the algorithm, I guess. Okay, so we'll just have a simple switch case here for our command, and we're gonna have a case move. Oh, right. And we will have a counter for our arguments. And every time we go through here, we will increase that. We'll have that here. Okay, and so if we have a move command that we want to make a move, right? So we'll just simply call make move with our game. And we also have to parse the move, which we haven't set up yet. So this, we'll just comment this out. And if we do a perft, oh, also we should have a bool command end for when we end our move. If it's a command move, then we want to command end equals true, and then this is what will break us out of this loop. So that we don't execute make move on a bunch of different arguments. We do have to write a utility that parses a move from a string. So let's go to our parsing things, and let's go to parse move. So we'll just return a move. And we will take in a char pointer move. And how do we want to do this? Well, I'm going to assume that a move is going to be like this, right? It's just going to be two different positions, right? And so we can easily, we'll actually put this below our other stuff. We should really have all of this stuff in a header file anyway. So we're just simply going to assume that a move is 4 characters. And so we will do parse it should be parse the file for our move 0, right? And then rank, and then file and rank. And then if strlen if not move that looks like helix, it is helix. If strlen of move, oh my gosh, my headphone cable just scrolled my mouse. I hate it when it does that. If strlen of move is less than it's less than 4, we want to return something that isn't we want to return an error, to be honest, but yeah, that's what we'll do. We'll have an int parse move, and then we'll just have a this we'll do this. Oops. That's what you run to? Yeah, I love Helix. It's really awesome. It's also just really simple to set up, you know. So we want file start, file rank start rank. And then we're going to have to process this. Okay, so file and end. So this is where having this stuff in the header file is going to matter. Okay, we do have that as a thing. So start index will equal file and rank to index with our start file and our start rank. And then we'll do the same for the end. Okay, now what else do we need inside of a move? Start index will equal start index. That end index will equal end index. There is, love the toml config, but better than vim script and Lua. Yeah, it's very, very straightforward, for sure. We have to actually there's a question here of how are moves notated in terms of promotion. So let me go to the chess programming wiki. Let's go to perft results. And inside of here, this should give us a position where there is a promotion. And then we'll feed this to Stockfish and see what it says. We'll go perft 1 and just see. There should be a promotion here on B2. Oh, it should be black to move, that's why. So let's go to oh, these aren't the moved at all. Oh, that's why. You have to put in position fen. Is black in check in this position? What did it show? Paste was potentially unsafe? I'm not sure. I think it just does that when I paste things into my terminal. I'm not really sure. I use Ghosty. There should be a promotion at this. Let's try a different fen. Let's go position fen. This one should also have a promotion. Okay, there it is. This is what I was looking for. There are 4 different things here with an extra character, right? So we have to actually check for that. So that's going to be a different utility, which takes in a start and end position and finds the rest of the move data. And that's going to return a move. What we'll call this is start and end pause to move. And important is going to take in our game pointer game and our int start index and our int end index. And we're just literally going to find the pieces that are at our start and end. And yeah, this is becoming quite annoying, but it is what it is. Okay. You know what we should do actually? Just do an int for this too and take in the pointer. And this may seem unintuitive, but the reason why is we always want to check if start index is less than 0 is greater than 64, greater than or equal to. Okay, now we can actually get into the function here. Which is going to be, we have to do a couple of things here. So we just have to loop through our piece boards. Yeah, so I less than, we have to loop through both colors. And then we're gonna nested loop through piece types to check all of our boards at that location. So if check bit for our game pieces at a for the C color at I, and we're checking the start index first. If there's a check bit there, then we will fill in the piece type. And we'll have a boolean for found piece. And then we will have, we'll set piece equals I. And then we will also want to check bits for the game pieces ci at the end index. And we also want a boolean. Actually, don't worry about it. Let's not worry about it. Actually, we don't actually, I think, need this. We want move. I wonder how we check for en passant input. Let me look up en passant move notation. Yeah, it says that it's a that it's notated differently than this, but I don't know if we should really care about it. That I think that it should just be from start to end, in the Stockfish way of notating moves. So if not found piece, no piece found, we return -1. Otherwise, we want move piece to equal I. We also want to set move side equals C. And we want move yeah, I'm not sure what else. How do you do castling moves? I have to do a position with a castle. I think I already gave it a position with a castle, though. Like, in this position that I already have inside of here, it can castle. And that would be the king's spot, which would be E1. E1 F1, E1 F2. Oh, so it just says it goes to G1. Okay, so that's all it is. Okay, got it. Claude, please fix this. Make no mistakes. I wish Claude could fix my computer lagging. That would be sick. Can Claude send me some money? Can Claude fix the United States government? Can Can Claude make me another cup of coffee right now? Yo, Claude. I keep on getting these ads for Claude where it's like, Claude works with me, not for me. Oh my fucking god. Really? Really? Is it Sway? No, it's I3. This is actually going to be a painful process. This is going to be painful to figure out if it's a castling move or not. Yeah, that's going to be painful. Determining the move type is definitely going to be painful. Move type in this case. Well, we don't know if it's a promotion or a fucking. Oh my god. I don't use AI. I don't use AI either. They use Grok in the US government. Yo, shout out Elon Musk. I love that guy. Just fucking kidding. Dude, I'm so... Okay, let's just start simple. Capture piece equals I, okay? We have the side and we have the piece that we might capture, but we don't have the move type yet. We need to do some if statement fuckery here. So if our move okay, if our move piece is a pawn, okay, and then if our game en passant index equals the end index, then what we're going to do is we're going to say that this is an en passant. So if, and then our move, wait, yeah, for sure. The move type is going to equal en passant. And then our move, and then we also have to change the capture piece now. Well, it's always going to be a pawn that we're capturing, so move capture piece equals pawn. Okay, that's cool. Also, we have to check if it's a pawn, if it's promoting. And to what piece? Well, we already know if it's going to be promoting if the fifth character exists. So technically we don't have to deal with promotions. We don't have to deal with promotions here. Okay. Is Helix the best editor? I don't know, it's just what I use. I don't really think that there's a best anything. It's just kind of whatever you think is cool, you know? I think it's cool. We have parse piece, right? Parse piece with stir 4. Okay, so that will be our promotion piece. There. Okay, so if our piece is a pawn, Okay, but over here we have to check if we find a capture piece, it's definitely going to be a move type is capture, and we'll set default let's just have this as a I'm surprised I don't use tab autocomplete. I mean, maybe I do sometimes, but for example, if I am changing a variable name like this from start to end, I mean, that's kind of a bad thing. But if I'm changing one name inside of something, it's definitely faster for me to just write it out. For example, if this, right, it's going to come up on passant index. If I do this, then it fucks me. It fucks me because then I have to do that. It's just faster for me to write en passant, you know? So I think tab autocomplete is completely bad sometimes. But I use it sometimes, for sure. Like, if I'm going move, then I'll do this, right? I think we have move type out here. This is what I'm gonna do. And we'll just initialize it to 0, which is move, by the way. And then if we find a capture, then we'll just set move type to capture. That way we know it's always initialized to move. Actually, I'm just being really fucking stupid. And what we should do is move type just always gets initialized to move. And then if we find a capture, it gets set to capture. And then en passant gets set to en passant. The tricky thing is going to be checking if it's a castle. And that's going to be if move piece is a king. We need to check, first of all, we need to check our game. Brother from another mother. God, I wish that this was simple. I might, to be honest, I might just hard code it. Like, if I'm being completely real with you, I might just say if side is black, else if our move side is black, then we will be looking at the black indices. So if our move end index is which piece, which it would be index 2. And the move start index we're gonna do some disgusting nested loop shit here. I don't really care. This is going to be the queen side castle. So if we still have the castle flags, then that's going to be that. If our move end index is 2, then we know that it's a castle. Unfortunately, we actually have to check if it is legal, I guess. I think checking for legality is not a thing that we should do here. It's probably after it seems like I've made an engine before. Yeah, I've made not only, you know, chess engines, but game engines too. So I did make a chess engine before, but it wasn't perfect for sure. So definitely really try to improve it. But all of this stuff, this is just literally for us to input stuff into the terminal to make a move, specific move. So that's why I'm not really, I'm trying to like just hard code and push through it. So if the end index is 2, we're literally just going to set move castle side equals queen side, and we're going to set move type equals castle, and then move I think that's it. And then we want to do the same thing here. If the move start index is equal to 4 and our castle flags for black king side exist, then we will check the end index to see if it's, I believe that this one is it 5? It would be moving from here to here, so now it's 6. If we move to 6, and then this is king side castle. Okay, and we're going to do the same thing for white to detect the castle. So we'll just do this to white, and we need to change the hard-coded indices. The start index is always going to be 3, 2, 1, 0. Okay, so 60, and it will be going to 62. And then this will go to 58, I believe. Let me check this just so that 61, 60, or 58, yeah. Okay, that should be good. And that should check that should check that. And then outside of here, we will check the promotion. Okay. All right, peace out. Have a nice night or day. Thanks for hanging out. I'm just going to call this function start and end pause to move. We're going to need a game inside of here. And we will give the start index, end index, and a pointer to the move. This is going to be a pointer. And then we'll say at the end, if promotion we need a boolean here. We're automatically going to assume that it's a promotion if there is one more piece. So if move type starts as a capture, then we need to check. We need to do this. Equals true. Our move type will then get switched to promotion, and then our move promotion piece, promotion type will get set to promotion piece. Okay, so we need to go to piece. Is it piece type and color to piece, or no? It's piece to piece type and color. Okay, I mean, hopefully I did this all correctly. I don't really know if I did. Let me check what else is inside of the struct. For move, start, end, type, side, piece type, capture piece, promotion type, promotion capture, castle side. Okay, that should be it, hopefully. So finally, back to our input loop. We have to, we are just going to do this once. So parse move, we need that inside of our, I'm just going to return one here. We need to put this in the header. We're going to parse move for the game with the string, which is going to be the current L, and we want to have a move, and it's going to be mad at me because it wants me to scope this, so that's what I'm going to do now. We'll scope that. So move, move, and we will parse move and give that, and then we will make move. Okay. Okay, so if I did all this correctly, it should be able to make a move. I want to make a new command though. Under command type, that is going to command command Lag again. So annoying why this, you know, lag, always. Okay, so if we have a command for a display board, what I want to do is just print the board. So we're just going to print game board for our current game. Okay, and then command end is true. We also need to put the string compare up here. We're just going to say that that's display just to keep it simple. And the last one was, oh, that was the last one. Okay. Okay. So we're gonna go down here. Hopefully that's fine. I want to do the generate moves next, which is just going to, now we need to change something actually. It's going to move generation. And what we were doing was just having a move list in here. Actually, what we want to do is we want to take that in. Yeah. We need a utility that does that. At the end of here, it should automatically be print move full, but I just want to... we also need a count. Okay, so let's put this in utilities, like I just said. Okay. Okay, no clue how this is going to work. Why is it mad at me? Passing, okay. We also need a command to quit, so that's what I'm gonna do now. And how we're going to access this is that we will extern that running int variable, and I'm going to do that down here. Okay, I wonder what's going to happen when I build this. Okay. Now let's see if I can input a command. And my command is going to be generate. Incorrect file character detected, returning -1. Move out of bounds, invalid move. Interesting. So it is getting inside of move. Oh. No, it's never getting inside of generate. So it defaults to move. Interesting. Oh, I'm being dumb. I'm doing the thing. I did the thing. You have to do this. I forgot about this. For whatever reason, I mean, string compare is, you have to make it equals 0. I was confused there for a second. But it's working as intended. So let's do generate. Let's see. Okay. The same thing is still happening. I'm assuming quit isn't going to work either. Is it because of... okay, so if there is no space at the end, then... Interesting. Is it possible for me to just like... Is this possible for me to just do this? Okay, that works. Okay, so let's go to generate. And it generates the moves, which is correct. There are 44 moves for this position. Now let us see if we can make a move. So we're going to do move E1, D2. Invalid file character detected. Returning -1. Interesting. Let's try move move E1, D2 with a space. Interesting. Huh. Let's try capitals. Huh. Try capitals with a space at the end. No. Okay. Interesting. Okay. So that isn't working. It is getting into here, but it's giving me invalid file character detected when we parse the stir 0. Oh, it's because, okay. We need to, in this case, we need to L equals stir talk null, and then if L, then we do the move. Invalid move. Let me try this. Invalid move. No piece found at start. Invalid move. Let me print out the current board state using, what did I call this command? Display. D1 definitely has a queen. No piece found at start. Okay, so let us let me print L is whatever L is. Okay, so the string is correct. Let me print move full with the move when we get it out of this. Move pawn A8. Interesting. A8. So parse move isn't working with the parse file and the parse rank. Obviously. Man, I don't know. So this will give us this, and I want to get the file names just to debug this, indexed by the start file. So let's see what it tells us. Parsing file D to file D. That's correct. Gives us the correct file. Oh. Ow. Ow, ow, ow. That would be why. Okay. So 1 is going to 2. Really? You know what, maybe this is... Okay, so when I parse rank when we set up our game board, I actually think it's a different... Maybe, you know what, I never actually tested this en passant parse rank. It may be rank -0 plus 1. Because this would fix it, I think. No, that goes up 1. Is it this? That gives us the correct location. However, this is a bishop when it shouldn't be a bishop. Which makes me think that my my whole thing is messed up with the I should take a break soon. I think that I'm getting the correct rank. No, but the start and the end index have to be correct because wait, no. Let me check this. Let me check this. Oh my gosh, lag. So it says 59, which is correct. This is 59. And 35 is here. Is that 35? 0, 8, 16, 24, 36. 38. Wait, no, it's D4. Wait, what? But that's... Oh. Okay, so it has nothing to do with this. But our end index is definitely wrong, I think. This may have been off. Oh, this is so weird, man. Alright, I need to take off my jacket. I'll be back in a second. Okay, I'm back. Hi, back. Okay, so what I realized with this is that we're incredibly stupid. Of course, there is still a issue with this end index, but all of this is pointless that we've been working on for the past hour. I realized that all we have to do is we parse the move. We give the start and end position, and all we do is we just literally search through our generated moves for a move. Yeah. So, what this is just going to give us, this parse move, is just going to take in end pointer for the start index and an end pointer, or actually, you know what, we're just taking that move and then just set this is all it's going to do. And then what we will do is all we have to do is generate moves. Like this. And then and then we just have to find a move based on the start and end position. Sorry, I'm not talking that much. Okay, so if we have a promotion piece, then yeah, so we're gonna select which promotion to do. So oh, hey Hamish. That's an interesting message. How did you find this? Yeah, I was thinking of doing it like we just search until we find the correct promotion. The issue with this is that if we find a match that isn't a promotion, so you can't do this inside. You have to actually do this outside. You have to literally just swap these, but you really don't want to swap them. I'm overcomplicating this. Else we can just return the pointer to this entry. Yeah, this should be fine. You just don't have the ability to throw this error, which sucks. But it is what it is. Why is my indenting messed up so much here? Yeah, that's fine. Yeah, then you don't need to nested loop this. You can just put this in one thing. And then this becomes a lot less verbose. Okay. So we will put this, this is an imparse move. We're just gonna put this here. So, oh, we need to put this in the header. Okay. I want to put this, it's fine to put this here. Why is this song so sad? Okay, find move, the move list. This has the start pause that we just initialized into this move. So why are you mad at me? Oh, you're mad at me because start index. I have it named wrong. And yeah, so this is the part where parse move, it's going to return something if there is a promotion. So right now we just return one, but we want to do something, we want to return a different code. So if promotion, I want to return 2, and we should probably enum that, but just give me a second. we also need the piece. Yeah, so that's what we will have here. We're gonna take in a pointer to a promotion, or no, piece type. I'll let the promo piece, and we'll say if we have a promo piece pointer, then we will dereference it and set that to the we can call piece to piece type in color, but this doesn't return a promo piece. It returns a color, so we have to pass in that pointer to that promo piece into here, and it takes in the raw piece. So that's that. And so we're going to fill in that promo piece and then return that too. And so outside of parse move, we're going to say the code that we get from parse move, we can comment what this means. So if code is 2, I'm just coding this really fast since this is just gonna be on my end for debugging right now. So if our code is 2, that means that we have a promo piece, that it's a promotion. And so let's just have a bool promotion outside of here, and if code is 2, then promotion will equal true. Yeah, this is a really funny way of going about this, but for now it is what it is. So we'll just pass in that variable and then the promotion piece that we will set up here, and that's going to be a piece type promotion piece, and that's what we will pass in as a pointer to parse move. The reason it's giving me an error is because we need to put this in the header under parse move. Cool. I recently started learning Vim, and it's pretty cool to watch me coding with it. I hope one day I can code like you. Thanks. It's actually not Vim, it's Helix, but it's very similar to Vim. Very, very similar. It's basically just Vim, just with some easier setup and multiple cursor stuff. Like you can do funny stuff like this, you know. Plugins in Vim that do the same thing. Anyway, so we're gonna find move, and then we'll say move found move equals find move. Oh right, it's a pointer, and then if not found move, we're gonna say no move found. This should be its own function at this point, but whatever. Okay, so hopefully this kind of makes sense. Now let us compile this, and let me see. Let me see. Let's generate moves, and then let's play move E1 D2. Gives me invalid move. Let me display the board. So this is a king move. It's giving me invalid move. So it does find the move, it just gives me invalid move. If not make move. Return in check. Game inside. Interesting. So it says that we are in check at the end of this move, which shouldn't be true. That is definitely the what I think is happening is that this is the only point where we print out invalid move. So that's what I'm. We don't print it out from inside of find move, right? No, we don't. So in that case, inside of parse move, do we print out invalid move? No. No, we don't. We don't. Unless this is returning -1. But we do end up parsing file E to file E, so that isn't the case. So we do find a move. And we print out the move. Move pawn E1 D2. Promotion none. Oh, that's the issue. Move P. Huh. And print move full. It uses piece names with move piece. Oh. That's why it's giving me pawn. It's not actually pawn. This is not correct. This would be piece piece type and color to piece, I believe. And we have to yeah, so this is going to take in the move piece and the move side. That's what it is. And then this is what we put into here. Excellent. So what was happening there, if I can explain it correctly, is that there was there's two different enums that are happening at the same time. There's piece type and piece, and one has color embedded inside of it and one doesn't. And so hopefully when we build here, we display and then we generate our moves. Yes, so now we're getting the correct one. So if I do move E1 D2, I doubt that this is going to work. Now it still tells me invalid move, but it has a pawn here. Which is interesting. Let me try a different move, D1, D3. It all is coming out pawn. C4, F7 capture. It all comes out pawn. What does that tell us? Black pawn, by the way, is actually the very first enum. So that probably tells us that huh. Oh, I'm so stupid. I was printing out and using the move and not the found move. And this is me being very dumb because this is me being very dumb. Okay, now this should work. So let's generate moves and let us make a move E1, D2. Okay. We made the move. Display. Okay, so we have an error here because our king is in two different places at once. And it's actually a black king. Interesting. And isn't there an extra space on my board? Oh, because... Okay, interesting. I wonder if our side to move is correct. I'm gonna assume that we're making move... correctly. Maybe the whole not side thing doesn't work. I'm kind of interested to see, to test some more with this. So E8, F8. Let me see. Oh, move E8, F8. Okay, and then let me display. Okay, so we're ending up with a king on both the black and white piece boards. Interesting. Board pieces both, toggle bit, set bit. And the side to move pieces. Toggle bit, set bit. Very interesting. Let me try some other pieces. Let's try H1, G1. H1, G1 is an invalid move. Why does it appear on my move list? White rook H1, G1. There's no rook there. No, there is. And then it says invalid move. It says that it puts me in check. Definitely shouldn't be putting me in check, though. Huh. Let's try H1, F1. Invalid move. Let's try C2, C3. Invalid move. This is white to move, right? Why is every move that I check now not working? Huh. So it seems like only king moves are working, actually. Interesting. I'm assuming that everything that isn't a king move is a... Oh, here's an insidious thing, is that there's multiple kings. Here. There's a white king on top of the black king. For a few of the moves. Also, these are not the correct side. Interesting. Okay. So it isn't a problem with our make move. It's probably a problem with our generate, I guess. Okay. So how do we fix this? Let's take a look at exactly D7, C8, by the way, these are all actually white's pieces. They just aren't getting the correct so we do pawn, knight, and then bishop, and then by the time it gets to bishop, then the side is changed. Side changes here, and then side changes here. And then side changes during the king captures. Huh. How is our side changing? That's so strange. Side should never change. I wonder if it's there was some stuff that we just didn't do here. I wonder if it's a problem with the promotions, actually. Okay, let me take a look here. What else do we need here? Side equals side. Oh. Oh, hold on a second. We weren't setting side. Oh. Snap. Oh. Well, that would be why. That would be definitely why. We didn't have side inside of our pawn generation. And I'm going to assume that I'm going to find the same thing. Oh wow, I find the same thing all the way down actually. And the reason it was working before was because we didn't take side into account. So that would be why. Let me make sure that we're not actually overwriting that. So side equals side for all of this. And the reason why we have to pass in all of this side data is because we don't want to branch later on down the road. So we did have it for sliding pieces. We did have sliding pieces there. We did. There we go. And find and push captures should, it also has side. Okay, perfect. Now for our pawn promotions, it's actually now a promotion type is going to be what we push as the piece, right? So it's going to go knight. That should just be, yeah. So knight, knight, bishop, rook, queen, right? Okay. Queen. Okay. Something else that's kind of important here is yeah, so we need to also potentially push in our promotion captures for if it's a promotion and a capture. So I need to get that information somehow. We remove the captures from the promotions here, but I need to know actually here which promotion is a promotion capture. And that means, to me, what that means is that we have to find and push captures all the way down here. And only remove the promotions from the captures after we're done here. Because we want to check if our promotion is a promotion capture, and if so, we want to put inside a boolean. So we're going to say bool promotion capture is going to equal the set bit of 0 at the index of this move index, and we are checking this against the the captures, just captures, I guess. And then we will pass in that boolean to promotion capture equals promotion capture. And the annoying thing with that is that we need a capture piece. Yeah, so this gets actually pretty complicated. Gets pretty complicated pretty fast. But we can do that fairly simply. And inside of here, we just want to loop through in the same manner that we loop through the find and push captures. We just are going to do this kind of embedded inside of that, inside of here, inside of our pawn moves. So if promotion capture, then we need to loop through our piece types for the other side. So so we're checking the captures and game pieces. Right. So instead of this, what we actually want to check, I'm going to just check the set bit of 0 and the move index again. And we just want to check this is just going to be a Boolean actually. So if we find a piece there, then we know which piece. And so we're just going to make an empty promotion piece here. No, it's just going to be a piece type. Promotion capture. And we will initialize it to 0. Promotion capture piece, sure. And then we will set promotion capture piece to I. Okay. I hope that that's the optimal way to do this. And then the capture piece will get set to promotion capture piece. I'm happy with it. And that way we know if we have a promotion capture, if we have a promotion capture piece, and what the piece type is that we're capturing in that case. Okay. So, with all that being said, I wonder if the bug is fixed or if there's something else we need to look at. So immediately we can see that it's all capital letters, which means that all of our moves are white. So let's try the E1, D2 that was giving us problems earlier. And we still get invalid move. Interesting. And let's take a look actually if this is invalid. So E1, D2 is definitely a valid move. Definitely, 100%. So let's try move E1, F1. I put it in wrong. E1, F1. Also says invalid move. Okay. Now it's giving me only invalid moves. Interesting. Oh, wait. E1, F2. Capture invalid move. It says that I'm... Okay, so here's... Okay, let's try something else. Let's have make move always return true. Oh, this is the opposite. That's probably why. So let's try this again. Move E1, F1. Display. Okay, there we go. We moved. now we generate, and we're getting black's moves. Okay, so that was the issue, was that we were returning this. So in check returns if we're in check, and I was using it in the opposite way. So whenever we were in check, I was saying that we weren't in check, you know. Anyway, so I think that this is working as intended. What other command did we want to check before we went down this rabbit hole? We have command quit, which we checked, generate moves, display, and move. So we checked everything, and if it's typing quit, we should quit. Now the perft is going to be the next thing that we set up, which is going to be interesting. Anyway, we have our make move and undo move, which hopefully is working. I'm not really sure if it is, but we don't actually know how to check it until we do our perft, which is going to be the next thing we do, I guess. I suppose we should put it inside of game is fine. This is getting to be a large file, but I think it's still at a point where it's fine. So perft. Perft is a recursive sequence of generating all the possible moves for a position, and then basically giving us numbers to see if we are generating all the possible moves, and if we have a problem with either overshooting and giving illegal moves or undershooting. So we're gonna perft. We're gonna perf for the first time. I have to remember how to do this though, and it's not straightforward at all. It's complicated. So we're gonna take in our game. What else do we want? We can take it in int depth. Okay, take it in depth. Depth is how many moves we're gonna go in, right? Okay. How do we do this? If I remember correctly, you have two functions. You have the perft at the top level, and then the recursive one underneath it. Then let's just have this perft up here, and then let's call this perft root. Okay. So okay. So the way this is going to start is that we're going to start just how we generate moves in the first place. Is we start with a move list that we always keep at 400. We should really have it defined for that. I will have that later. So, and then we're going to have a move count, which we initialize to 0. This is how we always generate moves, right? Now, inside of this, we are going to for loop, right, through all of our moves after we generate moves. Okay, so we generate moves for our game with our game side to move. Takes in our move list and a pointer to our move count. Okay, and that will generate moves into the move list. Okay, then we iterate through the move count and perform those moves. So we are going to say move pointer move equals the pointer of the move list to I. Okay? And we want to make that move. So we are going to have an if here once again. So make move for the game with this move. And we are going to do that, right? So if we can't make the move, then we undo move, okay? With a game and that move, okay? Else, this is if illegal move. Else we actually are playing this move. If else we are going to call perft with the game to the depth. Okay. So yes, this is fine. You want to go depth -1, right? And that way you have a way to exit out of the recursion. So this is going to start at 5, and then it will make its way down to 0. And at 0, then we will exit out. The reason why I have this at the top is because of keeping track of how many nodes. I think that if I remember correctly, there's some... I have to look at the perft chess programming wiki. Right. This is exactly what we have right now. I'll show it for the stream. This is exactly what we have right now. Pretty much to a T. So basically, we're calling perft, and perft is going to return an amount of nodes that it's found, right? Right. So the nodes, you add the perft below it. So this is going to return returns node count. Okay. And the reason why you put this as UN64T is because you want to make absolutely sure that that you have enough space, right? So this is going to be node. Let's just make it nodes to make it simple, right? So the reason why I have this separately for the root is because we want to print the perft after, print the results, and we want to print the results at each depth, I believe. I forget. Maybe. You always want to undo the move at the end. I'm wondering if you do need a perft root or not. I think that there was something with the nodes thing being weird. Right, so for each one, it gives a node number. So I think that that's why I had a root, is because you want to also print out this, let's have a UN64T move nodes, and then we'll have the nodes add that move nodes. And so we'll print out the master nodes at the end, but we also want to print out the move nodes during the move, right? So we're gonna print move full for this move, and then the nodes. I'm just eager to get into the test, to be honest. I'm super excited for it. Move nodes. This is an LD. And then at the end, we want to print total nodes. I'm lagging quite a bit right now. Okay, so that's that. I want to uncapitalize that. Okay. So let's write the perf underneath it, which is going to be this. It's going to be very similar, right? Except we aren't going to print out. We're just going to return out of this instead of printing. Okay. Print move full, we don't want to do. At the end, we want to return nodes. Okay. So, this should be kind of finished, actually. The only thing we have to do is check if depth is 0, return 1. I believe that it returns 1 for the end. Yes, you return 1. 1 ULL for UN64T. Now I'm kind of just... I wonder if this works. I wonder if it works. So, if we have a command perft, we want to run a perft root with the game to this depth that we're going to parse. We will do the same thing that we do for our move and get the next token. Okay. For the depth. So we need int depth equals stritol with L null as base 10, and we will pass that depth in. And then we want to command end equals true. Okay, so I don't know if this is going to crash my computer, but I'm super excited to see if it works. So let's take a look. So let's display the board, and then let's do perft 5. Okay, so 4-0. Okay, interesting. Okay, so there definitely are some bugs. There definitely are. Without a doubt. Without a doubt. Without a doubt. Let's see what Stockfish finds. It finds a perf 5 89 million. And I and I okay, so we have a bug for sure. Because both a white and a black queen are there. Okay, so let's if I know anything about any of this, it's probably an issue with our move and undo move. To be honest. But it could be anywhere inside of here. I want to test something. Let's restart and let's go to perft 2. Let's just do 2. 15, 17. I just want to find exactly how bad the... Okay, got it. Okay. So it's really not as bad as we think, probably. If we can go to depth 2 and only be a few moves off, it's probably not that bad. This is 62,000. Okay, and this is broken. Yeah, so it breaks at depth 3. The chain. Okay. Okay. So let's just make sure that our perf logic is correct first, right? So we generate our moves for our game side to move. Then if not make move, then we undo move. And we undo it at the end. And we call perft here. Depth -1. Got it. And then inside of here, we do the same thing. Everything looks correct. Okay. Everything looks correct. So that means there's probably a problem here. Okay. Perf 1 gives us 44, which is correct. Yes. So 1550. Wait, is that different than... Hold on. Oh, shit. Hold on. Wait a second. Oh, shit. Display? Ah, shit. Okay. So this is screaming to me that our undo move is wrong. Because we have a white bishop on top of a black bishop. Actually, hold on. This is 100% a promotion issue. 100%. Because this pawn promotes to a bishop on this square, and now there's both a black bishop and a white bishop on that square. And the reason that is either on our make move or on our undo move, we aren't doing it correct. Here's a good way to test this. So let's quit and then restart, and then let's try to display the board as it is at the beginning. And let's try to do the problematic move, which is d7 takes c8. 100% this is the problem. And now let's display. Yep. 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 Both a knight and a bishop end up on the square. Even though it should be a knight. Hold on. So let's restart and let's play this move again. Move d7 c8 and let's try queen. Promotion queen, this works. It's still broken. So this goes to here. And there's a bishop and a queen here. So this bishop so it does three things wrong. It doesn't remove this bishop. It adds both a white bishop and a white queen, even though it's only supposed to add a white queen. So, what I'm assuming is it's an issue with capture promotions, specifically. So if move promotion capture, Then not side, not side. This is on the capture side that we are toggling this bit. Absolutely, that is the issue. So now let's try this move again. What was it? D7, C8, Queen, and let's display. And that is the correct output. So let's quit out again, and let's try to do a perf to 2. And we find 1507, which is still incorrect. Still not correct. I do want to see if we go back to perf 1, our board state is messed up. And now let's go to display it and see where the issue is. We still have this issue with undoing, apparently, when it comes to promotions. So as you can see here, both a black and a white bishop are here again. This is an issue that still persists. And my assumption is that this is an issue with our undo move, and this is exactly it. The side was not negated again, which is exactly what we wanted to check for. So let's do the perf 2 again. 1496. So we have 10 extra moves. Now let's go to perf 1. Okay, perf 2, perf 3. Perf 1. Okay. Let's go to perf 4. And back to perf 1. Okay, so what this is telling me is that our board state is officially correct, because we're undoing back to the same exact perft. And if we go to display right now, our board is reset to the exact state that it was, which is exactly what we want. The issue is that we have some moves that don't exist, that aren't legal moves. So there's that. So I'm not really sure what we can do now, but what we're probably going to end up doing here is what I'm also interested in is when we perfed 1, where is our castle? Can't we castle here? Why can we not castle? E1. E1 G1 should be a thing, no? E1 G1 is a thing. Okay, so we actually have an issue with our castling. It appears. Oh no, it's here. It just appears that it's a move and not a castle. Oh no, that's E2. Oh. So I have the right number, but I have an incorrect move somewhere. I have an extraneous move. E1 F is also E1 F1, E1 D2, E1 F2, and E1 G1. Okay. Okay. What I ended up doing last time was literally just this. Is literally just going through all of our moves one by one. D7, C8, D7, C8. Yep. A2, A3, A2, A4. Yep. B2, B4, B2, B3. All of the pawns I'm going to assume are correct. And then hold on, D7. Oh. It's this D7 C8 capture. That's the issue. Okay, so now we know where the issues are. So we have a duplicated move with a pawn. So that's in our move generation for our pawns. We have a we were supposed to be removing the promotions. The issue is that we don't copy the promotions to a working board. So we have to uint64t promotion copy equals promotions. Let's make a note here. This is a working copy to remove our captures from afterwards. Since we need our captures during this loop to determine promotion captures. Okay, so if we use this promotion copy now we should probably okay, so we got rid of this move. However, let's go perf 1, or, well, perf 1 gives us 43. So this castle issue is still a problem. The issue with the castle move is that it says, it's probably saying that it puts us in check. The reason why I think that is because on the generate side, we are generating the castle move. But on the other side, we are not. So let's check what. Oh. That's why. There we go. Let's take a look here if I did this correctly. Perf 1, and we get 44 again. Yep. Okay, so what was happening was we switched our side to move. We switched our side to move right before we checked if we were in check. So we were checking if we were in check for the wrong side, which obviously is going to give us bad results. So let's go perf 2, and now we get 1510. Okay, so we're still not getting the correct amount. We need 1486, and this is where things get hairy, because we need to actually go through all of this and play these moves out. So if we promote to a queen, for example, we have one extra move. If we promote to a bishop and to a queen. Oh, actually, interesting. What's very interesting is that after this castle, we only get one node. Which to me is screaming to me that this is wrong, because e8... What is e8? Oh, e8 f8 castle isn't a right move. Okay, so our castling generation is incorrect. That's what this is telling me. Oh, well, that would be why. That would be why. Because we aren't actually, we're just, we were just using the black castling for both sides. Of course that this start index is going to be, we had this as a thing. Castle, oh, that was rook castle locations. So we don't actually have the places for the side, but we need to make that global. So we also need this for kings, king castle locations. And then inside of utils, we need to put this down. We need to make the same thing that we did for rook castle locations, so that we can avoid branching. So black queen side, it's going to start at, well, we have it right here. It's going to start at 4 and at 2. And then for king side, we have it here. It's going to start at 4 and at 5. Or is it? Wait, really? Is that how chess works? No, right? This is gonna go to 6 for sure. For sure. Yeah, I don't know why I thought that. Anyway, so this is going to be 63, 62, 61, 60. And then for queen side, it's going to go to 58. And then for king side, it's going to go 60 to 62. And that is what we're going to use inside of our move generation. Instead of these start and end indices, we will use king castle locations indexed by the side, for queen side, and it will be start and end. King castle locations indexed by the side, queen side, end. And we're going to do the same thing down here for the king side. Okay, and I want to give this a shot. I am lagging a lot. Let's take a look here. If we generate, do we generate the correct castling move? Yeah, we do generate the correct castling move. So let's go perf 2 1433, so we went down a lot. Still not the correct number, though. We are not getting the correct number. So perf 1, we do undo back to the correct state. However, we're still off. We are off by about 50 moves. I don't know why I assumed that we would just get it right the first time. It's a bit more complicated than, you know. I gave myself a lot of credit here, you know. Anyway. So, queen and rook are both 31 for promotion, right? So obviously that's incorrect. And then this is 41, 41. What is the command to make a move? Oh, brother. I'm gonna have to do this, huh? You're gonna make me actually go to the GitHub, huh? Oh. Okay. Okay, so I went to the README on the GitHub and it gave me absolutely nothing. So thanks. It's telling me how to generate moves. I just want to... How do I perform? Oh. Can I do... Is it... E1, G1? Okay. Okay, but how do I check if it did it? Oh my gosh. Okay, I think that that's the syntax actually, is that you have to do this. And then you go moves E1, G1. Can I do moves, position moves E1, G1? Okay. Then. Brother, give me some output. Go perf 1. Maybe I have to do position fen moves E1, G1. Go perf 1. Okay. Is that really the syntax that I have to use? That is so fucking awful. Sorry, but that's just awful. God, that's dumb. I don't mean to be like a jerk, but man, that's fucking stupid. Okay. Okay, so we're missing a bunch of moves. So the way we're going to go about this is we're going to go perf 2 on both. 1433 is what we get. And we're going to have to go through everything that isn't correct. So, for example, E1, F1, we know that this isn't correct. So I'm going to go on my engine, and I'm just going to move E1, F1. Okay, and we're going to display to make sure that we moved it correctly. So E1, we moved it to F1, which is correct. And I want to perf 1 from this position. And we get 35, which is exactly the incorrect number. So we're going to go do the same thing here. Moves E1, F1. And we will go perf 1. And now we have to look through these lists and see which move we're off. This is the most exciting part of making a chess engine. So C6, C5 we have, A7, A6 we have, B7, B6 we have, F7, F6 we have, G7, G6 we have, H7, H6, A7, A5, yep, B7, B5. You know what, I'm just going to ignore the pawns for now. I'm 90% sure that it's a king or something, right? So let's see, F8, G8, D8, E8, D8, E8, yep, F8, E8, F8, E8. That's it. F8, E8 is what we're off. F8, E8, F8, E8 is attacked by a pawn. It's attacked by a pawn. Actually, yeah, so this is interesting. So perf 1 gives us F8, E8. Let me check our perf command here just to make sure that we're not crazy. We're absolutely only doing it when it's, yeah. So we are definitely considering that a legal move, which means that our attack mask for pawns probably isn't correct. Pawn captures side index. This looks absolutely correct. And then we sort with game board pieces side for our own side. I want to see the attack mask. I have to figure out how we're going to debug this, though. I really want to print out the attack mask, though. If I can do that somehow, without just like flooding it with stuff. F8, E8. It's a white pawn. Okay, here's what I'm gonna do. I wanna... I'm gonna print board for these attack squares with a piece of, I don't know, black pawn. Okay, I'm gonna print out before it attack board just to know what we're doing, and I will see how so perft 1, we're gonna get a bunch of attack boards before all of our moves. So the problem move that we were doing, I believe, is the E1 F1. Yes, so let's do move E1 F1. Okay, and then let's take a look at our generated moves. So let's go to generate, and we will see all these attack boards here. Or actually, no, we won't. Generate, and then we see this attack board for the opposite side. And let's take a look. Let's go to display to see what the actual board looks like. And let's take a look at this attack board that we generated. The attack board seems to be correct because we have a pawn here and we have these two spaces, right? Yep, and for white, this is all of this, right? Okay. So for whatever reason, when I perft 1 and we do F8, E8, which is the illegal move, I believe we're checking for an attack mask with the wrong side. We're creating our attack mask with the wrong side now. That isn't the correct attack mask. There it is, 1489. Which we'll put in the start position string again into Stockfish. I believe that that's the correct 1486. We are 3 moves off at depth 2. 3 moves off, which should be fairly easy to track down. Let's go perf 3. Okay, well, we should probably get rid of the attack board printout. I think that that's just going to take forever, huh? Yeah. Yeah, there's a lot of moves. So let me get rid of that attack mask printout for this. And let's just see at perf 3 how we're looking. Oh. Well, that's a seg fault. 62906. So the number does get bigger as we go down, right? Let's go to perf 4. We start to get pretty slow. And we're off by something like 30,000 something. But I want to see if we go to display the board at the end, we undo the moves perfectly. So that's what I care about. 6 hours straight, no fatigue. Yeah, no fatigue. No fatigue at all. Okay. So, I mean, that's pretty amazing to me that we do, 2 million moves and then undo them perfectly. That's pretty fun. How long is our perf 5? Oh, God. It's so long. It's so long. It's so incredibly long. Oh. Yeah, this is quite long. I wonder how bad this is that it's this long. I don't have any optimizations, you know. But this is quite long. I can't remember if my old engines was this long or not. I think for certain positions it can get pretty long, but yeah. You know, an optimization we could make is that we could just not move our king to places that that we already found in our attack mask. I feel like that wouldn't even do anything though. Whatever. I'm not going to focus on this right now. I'm going to focus on getting our perf results correct. I think that that's the goal. That should be the goal. $14.86 versus $14.89. The thing is with these things, like a small number like this is actually probably one of the only bugs that is here, you know, inside of the engine. So what we're gonna have to do, unfortunately, is I think like the best way to probably do this is to probably do something like this, and then literally just go through the side by side on this, you know. The pain in the ass is that they aren't in order. So, E1G1 we have 34, E1F2, E1F2 we have 28, E1D2 we have 34, E1F1 we have 34, D1D6 28, D1D5 we have 35, D1D4 we have 34, D1D3 we have 34, D1D2 we have 34, H1G1 34, H1F1 we have 34, C4F7 32, C4E6 we have 35, C4A6 we have 33. So the first problem is going to be this C4A6 that is 34, 33. Okay, so we're one move up. So I'm going to perform that move on C4A6. So we're going to move C4A6, and we're going to do the same thing here. Moves C4 A6, and from here we're going to go perft 1, and that'll give us 33 again, and we'll go perft we'll do perft 1 here, and that gives us the 34. And now we need to go through here and figure out which move is the incorrect one. And hopefully it screams out to us. First of all, I'm looking at this move B here at C4A6 that is out of order. So that's screaming to me, right? It should be screaming to me because... Oh no, that's what we just moved. Never mind. Never mind. Okay, so for now we'll just ignore the pawn moves. And usually the problematic moves are king and queen moves, so that's what we're going to look at first. There's one king move down here. That's correct. D8, A5, D8, B6. I'm looking at the queen moves. D8, C7, D8, E8, D8, D7. Hold on. Sorry, I just had to check the time. H8, G8. That's correct. So we have one extra move. E7, A3. E7, H4. E7, H4. E7, B4. E7, G5. E7, C5. E7, F6. E7, D6. E7 F6, E7 D6. C8 D7. C8 D7. F2 H3. F2 H3. F2 T3. F2 G4. F2 E4. F2 D1. F2 T1 capture. F2 D1 capture, there it is. F2 H1 capture. Yep. B8 A6 capture. B8 A6 capture, there it is. B8 D7. There it is. C6 C5. C6 C5, there that is. And all I have left is pawn moves, which is weird. H7 H5. H7 H5 is there. H7 H6 is there. Wait, hold on. Yeah, it is. G7 G5. G7 G6. F7 F5 and F7 F6. Yep. B7 A6. B7 B5. B7 A6 capture. B7 A6 capture. B7 B5 move. B7 B6 B7 B5 A7 A5. Oh, don't tell me that it was the very first one. And I worked the way from the bottom in the wrong direction. Oh, it is this one. A7 A5. Let me display. A7 A5. I see. Ah, this is the issue. We have pawns jumping over other pieces. That is the bug, and it's incredibly correct that that's the bug, because I didn't actually program anything for that. Shit. You know what we could do? We could do something funny here. Where I have an idea. The issue is that this is going to actually... The issue is that this is going to shift us down, too. I was going to bit shift it all down, based on our side. Oh, but that would shift our piece down, and then we'd be covering ourselves. Okay. Okay, so here's the thing. Okay, we're gonna have a UN64T board without our pawns, and that's going to equal the game board pieces for both. Ordered with our pawns. Actually, we have to use the raw mask that isn't being looped through. Board without our pawns would be that Zord with that, right? Yeah. And then we want to shift that in the direction that we move. Okay, so let's make a global inside of type.h. Let's do extern int pawn direction, or let's just call it push direction. And then let's put this in utils. Actually, this is going to be an array, of course, by color max. And that's what that's going to do, is inside of utils, our push direction is going to be, if we are black, then we're going to be pushing in the positive direction, and if we're white, we're going to be going in that direction. And so what this is going to do is we are going to actually, whatever. For now, let's just do this. We can try to figure it out later. Board without our pawns is going to, we're going to shift it this is going to go 8, but we have to figure out which direction this is going. I think that this is correct. I'm almost interested to see if this just works. We will find out really fast if it doesn't work, though. 1487. That's still incorrect, right? We're one move less now. What move was it? C4, A6. So let's perform this move again. C4, A6. Let's display to make sure we're good. C4, A6. Yep, that bishop moves, and let us go perf 1 to see if that fixed it. And that did fix it. That did fix it. Okay. So that fixed that. However, we obviously still have things to fix, I guess. Okay. So still our perf 2 is off by exactly one move, which I'm pretty happy with. We still have to find exactly which one is problematic. So we can do some deduction here. And immediately I find where it is. It's the promotion to the bishop. We have one extra node right here. D7, C8, bishop. So let us do this. Do this move. We're going to say moves. And that is D7, C8, B. Okay, and let's see. Let's make sure that this was the correct one. We're going to get 41, right? Right. And for us, we're going to get 42. So we're going to move D7, C8, B. D7, C8, B. And we will display to see what we just did. So we went from D7 and we promoted to this bishop, and that it looks correct to my eyes. But we can do perf 1 and we actually find 41. Interesting. So this is the very first problematic thing that happens sometimes. I remember this happening last time where you end up doing the moves to the correct point, and then from this position I find the correct number of moves. But the count is off when I'm perfting from up here, right? So that we get 42 instead of 41. But now I'm getting 41 from within the tree. And there's no easy way of figuring this out. This is something that I struggled with for a while in my last engine. What we're going to end up doing to debug this is we will temporarily print out the moves at a lower depth during our perf. Okay, so we will print move full for our move, and I want to printf the way I do it is if our depth, we're just going down depth 1, so it doesn't matter. We're going to print out our nodes move nodes. Okay, so let's try to do this one more time. Let's go perf 2. And as you can see, now we have the second echelon of moves. However, this is going to be really hard to parse through. How did I do this before? This is how I'm gonna do it. Okay, so the problematic move is d7 c8b, and in this case we are going to have a bishop, a white bishop at c8. And so what I ended up doing is only if there is a white bishop at c8. So if check bit, the game pieces for white, bishop at c8, which is index. We can. God, I need a visualization to count. What is that? 0, 1, 2? That's a 2. Then we will print out. So let's try this. Perf 2. And as you can see, now we only get one set of moves. And how many is it? We don't actually get a count, but I'm sure that this count we can prove it down here. We can prove it down here. 42, exactly, which is one more than we want. And now we get the exact list to check against, to check exactly where the extraneous move is. I know, riveting stuff. Riveting. Riveting, riveting, riveting. F8, G8, F8, E8, D8. I wonder if it's going to scream out at me or not. There's a lot of D8s, man. There's a lot. We can just straight up count them down. Right? They're all in a row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm just going to assume that that's correct. H8, G8, that's correct. E7, E3. E7, H4. E7, P4. E7, G5. E7, C5. E7, F6. E7, D6. Okay. We should be going in the other direction, I just realized. So the E7s. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. F2s. Let's go to the F2s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 2 B8s. 2 B8s. And then C. Then it's pawn moves. Okay. C6, C5. C6, C5. A7, A6. Wait, I should be going from this to here. I just realized. Oh. I was going in the wrong direction. Since I have an extra move here. B7, B6. Yep. B7, B5. F7, F6. F7, F5. G7, G6. G7, G5. G7, G5. Yep. H7, H6. H7, H7, F, H5, yep. C6, C5, yep. B8, D7. B8, A6. Okay, this is very strange because I think we have the exact same amount of nodes, but the count is off. Unless I messed up somewhere, which is possible, in terms of me doing this by eye. Wait, hold on a second. F2, D1. No, F2, D1 is there. F2, E4. F2, G4. F2, D3. F2, H3. E7, D6. E7, D6. E7, F6. E7, C5. E7, G5. E7, B4. E7, H4. E7, A3. H8, G8. Yep. D8. D8, C8. D8, C8 capture. D8, D1 capture. D8, E8. D8, C7. D8, D7. D8, B6. D8, D6. D8, A5. D8, A5. D8, D5. D8, D4. D8, D3. Fuck. Fuck. Fuck, man. So let's do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Fucking, why is it so hard to count? Okay, 1, 2, 3, 4, 5. Yo, what's up, Frumpy? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 40 fucking 1. So the count is off, and there is 41 moves here. Correctly 41 moves. It's just the fucking count is off somehow. What? How is the count off? You installed the i3 on Gen 2. That's sick. Welcome to the club. And the full nodes does get 42. The full nodes does get 42. Okay, so here's what we're gonna do. We're gonna print out the nodes and the current node count, just so that we know we're not going fucking insane. No, I mean, I think I'm going insane. I think I'm going insane. Wait, what? Okay, somewhere we have to count twice, right? Five, six, seven, eight, nine. All right, peace out, Frumpy. Have a blast. There it is. There it fucking is. D8C8 capture. We get nodes 1, but our current node count goes up by 2. What? Wait, how does that happen? GDB the king? Well, this isn't GDB. I'm sorry, but this is not. This is no. This is not a memory issue. We're incrementing. This is so strange. I think I had this problem once before, though. I'm gonna go fucking ballistic here. Yeah, it's strange. Unless our depth is... Let me do this. Still. D8C8 capture. The thing is, move nodes is 1, and that's the only time we add. So how do we end up adding 2? Oh. I see. I see. It was confusing us. It was confusing us because of this check bit. Because of this check bit. We are actually, that's what's happening. We move this bishop, and therefore we are no longer within this thing. So what we actually have to do, this is why that was very confusing. So this is what we have to do. We have to do a bool print equals false, and then just simply set that boolean here. and then we'll just say that print equals true, and then we'll just check that instead. That was very confusing. The line that we are checking, within this line, this piece goes to this position, and that's why, but of course, there is a chance that that bishop moves from that position as well. So now we get full nodes 20, 42, 42. There we go. And hopefully we can find around 27 to 29 should be the problematic move. What code editor? This is a Helix. This is Helix. So D8, C8. Is it D8, C8? Let us check here. D8, D8, C8. I don't see it. Holy shit, did we find it? Nope, D8, C8 is here. We have D8, C8 twice. We have D8, C8 twice. And that's probably why this was so hard to find. It's because we probably deduplicated at some point. But we have a duplicate move on our queen. Our queen. You can see it. Queen. Okay. Well, at least we know where to look. The interesting thing, right, is that this D8, C8, isn't this D7, C8, and then we promote to a bishop. And then after that, then D8, C8 is duplicate. Okay. So let's look at our queen move generation. Would it be bad if I used Vim as my terminal multiplexer? I3 for your terminal. I like Tmux, but Tmux is hard. I think Tmux is what most people would use. I don't really care much for, I don't know. This is just I3. What this is. It's just I3. But I mean, find and push captures. There are moves and potential captures. Hold on a second. Do we remove our captures from our moves? Is that what we're messed up on? These are both captures though, it says. Right, we remove from our moves board pieces both. And then this is moves and potential captures. Okay, yeah, I'm not sure, I'm still not sure why this is happening. How we get a duplicate move. what we might have to do is to deep debug this and see where exactly it's coming from. I have no clue how it could be getting a duplicate move, because the captures would only have one bit at that. Oh shit, that's what it is. It's capturing, it detects that it's capturing two different pieces at one index. That's what it is. That's what it is. So it loops through all of the enemy side's piece types to find on its capture mask what piece type it's capturing. And it finds the piece that we captured. And in this case, for this move, D7C8B, I want to exit out here, and then I will display the board before we make the move. D7C8 takes this bishop. We do move D7 B8 D7 C8 bishop display. Interesting. Yeah, I'm not sure. Because it only happens in a certain case when we're... Well, we know where it's going wrong. I guess we just have to figure out what piece it finds. And if it finds this bishop, right? If we can check, so I want to check if our suspicion is correct, right? So if check bit for the game board for white bishop at the index of, is it 2? 2? And we have a bit for game pieces black bishop at 2. Then I want to printf. I want to print board that this is how we're gonna check. If my suspicion is correct, then when we do the perf 2, we should find at both of these positions a bit at the same exact position, which is impossible. We don't see it printed out. Hold on, I just figured it out actually. It's not a white and a black bishop, of course not, because that wouldn't duplicate the move. What it is it's a white pawn. It's a white bishop and a white pawn. And I can prove it right now. Yep, there it is. We printed out a bunch of times. And I'm proving it because if we have a bit at 2 for a white bishop and we have a bit at 2 for a white pawn, they're on top of each other. And so if we're printing out boards, that means that, as you can see, our bishop is here and our pawn is here. Bishop here, pawn here. So, there's one of two things that are happening. It's either in our make move, where when we have a promotion capture, if move promotion capture, that is what it is. If it's a promotion, we do not toggle bit. If it's a promotion capture, we toggle the piece that we're capturing, and we toggle the other side pieces. Move promotion type. No, that isn't it. That is a piece type. It's either an issue with the make move or the undo for this. That's what it is. It's an issue with this. We don't actually want to toggle at the end, because we'll be toggling it back. We only want to put it at the start, because we never had a pawn at the end. You never have a pawn at the end. Here inside the move pieces you do, but there you don't. Let's see if we just fixed it. Yep, 41. There it is. The golden number 1486. We have reached it. So let's go back to this to make sure that we have reached the correct number. Go perf 2, 1486. There we go. Fantastic. Okay. So that was the bug. Took us a while to track down, but that's just kind of, that is how the stuff works, to be honest. It's just kind of painful to track things down sometimes, because when it comes to recursion, you know, it just becomes painful. So we're gonna get rid of all this debug, but we're gonna keep it there just in case for later. I want to also get rid of that print board debug for that was inside of our generate queen moves. Inside find and push captures. Yeah, so let's get rid of this. We'll keep it there just in case we need to have it later. But now we want to check perf 3 for this position. And we are off by 200 moves, it looks like. And if we go back to perf 2, we set it back up right? So we are off by about 200 moves, and that sucks because that means that we have more bugs to fix. And this is the tedious kind of incremental process that you go through with just looking through the move tree until we iron all of them out, right? I do want to check though, something that I'm just curious about before I head out is if we init new game, I want to see if we init new game, right? We set up our pieces. I want to see perf 1 get 20, and then for stockfish we'll go position start pause, go perf 1, we get 20. So this is set up correctly. I want to see what our perf 3 is. 8902. 8902. Okay, so let's try perf 4 from start position. Let's go perf 4. Okay, so from start position, it's 4 moves in where we see our first issue. This is screaming to me that it's a weird castling thing, or it's possibly an en passant thing. From my experience with what is probably going on, it's an en passant thing, probably, because that is exactly what would happen 4 moves deep, basically. And then we get our perf 5. Let's go perf 5. And we are only off by 100 or so moves at depth 5, which honestly, all things considered, I'm kind of happy with. I'm happy with it, you know. It's not perfect, but we're getting there. And being just this close already is pretty, it feels pretty good, right? Now, the perf isn't as fast as I want it to be, right? It really is not fast. As you can see, our perf 5 is fairly slow, okay, from start position, and our perf 6 is just never going to finish. That's just unfortunately the case, but hopefully we find a way to make it less painful later on. Yeah, it takes forever. Perf 6 takes forever. Yeah, I'm interested to see yeah, there we go. That's our perf 6. It took a long time. Took a long time. So our perf 6 is 119128, and that's where we're off. We're off about 60,000 at depth 6. But that's okay. Our perf 5 is okay. I think. How long is that? 1, 2, 3, 4, 5, 6. It's about like 5 to 6 seconds. I don't really know what a good perf is, to be honest. I don't know if I'm slow. But anyway, I think I'm gonna head out. I don't really know what this bulk counting is. I'm reading about bulk counting, but I'm not sure what that means. Legal move generators can take advantage of the fact that the number of moves generated at depth 1 represents the accurate perf value for that branch. Therefore, they can skip the last make move / undo move. Ah, I see. Oh, I see. Oh, I see. So that's kind of like cheating. But you would have to have legal move generation for that to work, right? I think you would have to have legal move generation for that to work. Because you'd be returning this move count. I mean, you could cheat it here, but no, yeah, you can't do it with that with yeah, I'm just reading about it. Yeah, I might do some profiling and trying to figure out how to optimize it. I wonder if the way I've gone about things is just slow, but yeah. I could also just like, if I wanted to optimize perf, what I could do is at depth 0, I could make a legal move generator rather than pseudo legal moves. I could just do pseudo legal moves for everything leading up to it, and then do legal moves at the bottom, just so that we can avoid make moves and undo moves at the bottom. But I mean, who really cares about perf that much? But yeah. All right. Also, you know what it probably is? It probably has something to do with checkmate. That's actually probably what it is. Hold on. Let me go perft 4 on both of us. 81 versus 299. Yeah. Yeah, so that's probably what it is. There are at depth 4, there are 8 checkmates that are possible. So that's probably got something to do with it. That we don't detect checkmate, right? So that's probably has to do with it, with why at depth 4 we're off by more than that though. We're off by 8 more moves. So it's not just checkmates. Something else for sure. Anyway, I'm gonna peace out. I've been live for a long time, so hopefully next time we can finish get rid of all the bugs with the move gen and get to a clean perf 5 on all the test boards. That's gonna be the goal, and then after that we can start scoring moves and stuff, and that's the fun part. So, all right, peace out. Have a nice night.